Welcome to EPF Day. Thanks for being here. My name's Josh. This is Mario. We coordinate the Ethereum Protocol Fellowship with the Ethereum Foundation, and this is EPF Day, where the fellows from the 5th cohort will be giving you lots and lots of demonstrations about what they have been working on over the past 5 months. Though quickly, we want to talk a little bit about what the Ethereum Protocol Fellowship is. This is a program that's been running for about 3 years now. It's been going through 5 different cohorts, starting with what was called the Core Developer Apprentice Program, started by Piper Merriam, and then Mario and I have been running this iteration of the program for the past 3 cohorts. The Protocol Fellowship is a program that is meant to steward the protocol through the bringing in of more and more developers. So according to the latest Protocol Guild statistics, there are about 180 developers that are working on the core protocol, all the things from specification to working on EL clients, CL clients, doing testing, and also doing lots of the research that is necessary for future upgrades and forks. So it's a lot of stuff that needs to get done, and not that many people to do it. As Tim Bako likes to say, and I think others, I'm sure you've seen this roadmap before, that each one of these tiny little boxes could use an entire team to focus on just that box. So we are here to try to fill in all of those boxes. The EPF, the Protocol Fellowship, has sort of grown a lot over the past couple of years, and we've been adding new features to it to enhance the experience and to make it easier for people who are interested in doing this work to do so. So it started with the EPF. Again, this is the 5th cohort. At the beginning of this year, we started the Ethereum Protocol Study Group, and that was a 3-month, 2-month-long program that offers some more basic introduction and overview to the different pieces of the protocol. So those people that are interested and maybe have some developer experience but don't really have much knowledge of Ethereum itself can get introduced to it and learn about the different pieces and parts and understand what it is that they might want to focus on. In addition to that, we've created a resource, epf.wiki, which is, the intention is for it to be the a go-to place for people who are interested in learning about the protocol to do so, answering questions and helping them to understand more about it. It is a growing and collaborative resource, so it is in its sort of fledgling form, and we welcome any further contributions to it if you are learning about the protocol or already are very knowledgeable about it to add your 2 cents to it. And finally, like Piper likes to say, the door to core development is hilariously wide open. You just have to step through. The EPF is a way for you to step through with somebody holding your hand a little bit. I'll go ahead and pass it to Mario.
Yeah, thank you so much. And let me tell you a bit about the current cohort. So, as Josh mentioned, we started this cohort, like I feel like this cohort started even before it started because we did a study group first. And it was a very special experience. We started with that this time for the first time, and there have been a bunch of people who came to learn about the protocol basically from zero and then joined the cohort. And in the last 6 months, or during this year, we started the study group like February, March. So like during this year, people who didn't have any idea about the core development became like almost full-time contributors in some cases. So yeah, it's been a wild ride. We had around 45 follows. Just some context to this number, because we started when we started the cohort, it's permissionless, anybody can join, and in these first calls we had like over 50 people, and we like 60 people who were interested in the fellowship, but then at least 45 of them submitted multiple updates throughout multiple weeks during like 2 months or something. So 45 of them at least made it to the second month. But to the very end, till today, we have 30 fellows who made it to the EPF day. There are a few of them who couldn't make it, of course, because of the travel restrictions and so on. But we had anyway, okay, put it further. Okay, 5 months of the echo. 5 months of the actual fellowship, which was first some learning part, first a month to figure out what projects these people want to even work on, and for many it was easier thanks to the study group. Than ever before. We had 2 weeks, two calls every week. So altogether we had over 40 calls together over past 5 months. We've met each other every week for the office hours, for the stand-up. So a ton of calls, but also we met in person. First time we met in person in Brussels. We had a chance to meet with maybe half of the fellows, but almost everyone is here today at Devcon. So it's really honor to actually meet you finally all after seeing each other at these calls. Yeah, so 30 people made it till the end with 30 projects. It's not one project per person. There were teams of people working on a bigger scope project together, which is also amazing to see that people learn to collaborate together. And we will have presentation for 20 projects today. 30 were proposed, yeah. And altogether we had like over 500 comments, over 500 updates in the repository. So when you open the development updates in the Cohort 5 repository with all of the tracking for all, every fellow, it's over 500 of them. So I guess not. I read all of them, but it's not really possible to do it by yourself. But there's been a lot of work done. And it's hard to summarize like what individual fellow did. I know that Rahul summarized it, so I kind of borrowed his data here just to give you an idea what is like the output of one fellow who dedicated like 1,000 hours to the fellowship. And how many coffees? 228 cups of coffee, yeah. That's interesting metrics that I would like to also use for measuring the EPF. But yeah, thank you so much for the numbers, Rahul. Like, so this is, and 26 updates just from one person. So you see, like, this is what the single person is able to dedicate to the fellowship over 5 months. And so with this, today, again, it's an honor to host the project presentations, to see your recap of what you've been working on in past months. And there is 20 of them. There is a lot of them. So we have a ton of topics to go over. I'm not going to even mention each of them because you will see them. This is the order, and we are starting with EVM memory repricing. So maybe let's get slowly ready to that. And yeah, we will have first half of the presentations in the morning with a pause at 1 p.m. 1:15, because we have 1:15. We will have 45 minutes for lunch, and then we meet here again at 2 p.m. for the rest of the presentations and for the panel. At 2, we will have a panel discussion as well. So that's the schedule for today. Please enjoy the EPF day, and yeah, I hope you get inspired by the fellows, by their work. I hope you are able to meet some interesting people here, meet with mentors and with other people that you might work in the future. Yeah, thank you so much for being here. And yeah, let's start. So yeah, let's not, if we have the first presentation ready, let's not even hesitate and get into it. Our first speaker today is Rahul, who was working on benchmarking EVM, on figuring out whether the gas pricing that we have is sound. And he got a bunch of interesting data. So thank you so much for being here, Rahul. Right? Oh yeah, wait. Is this one? Yeah, nice. Okay, thank you so much, Rahul. Go ahead, it's yours.
Yeah, thank you. Hi, I'm Rahul. I'm going to talk about EVM memory. I understand that EVM is kind of like an esoteric topic, but for the scope of this discussion, EVM is really just a computer, nothing to be scared of. Like any computer, it has like a memory unit, which is like a fundamental unit to store ephemeral data. Like to give you some stat, 30 years ago, memory cost about, for 1 MB, it cost $32. That's in 1994. Today, it costs about less than a penny. That's 0.00153. Any idea
repository is also doing. Where is the speaker that does this? Where?
Hi everyone. Excuse me. Oh, excuse me. Yeah. Let me have a look. Oh, okay. Hi everyone. This is Jess Fisa, and I come. Background. Breakout state DB and to replace the transitions. This is really slow and it costs a lot of CPU. So we want to introduce a real-time tracing system, which will offer more efficient and promote insights into the EVM execution, and it will also support indexing the left execution data, such as the traces, the state diff, and the other things. So let's see how can we go to how to index those left data. Currently, we support indexing the traces, which is grouped by a block, and so this is a block number and minus 2 the traces, and as indexing is based on the nonce. This is we want to index the transaction sender's address plus its nonce to our transaction hash. In my implementation, I'm using KVDB used to store newly created block traces and nonces. This is just a genetic KV database, and I use the ETIDB in gas. For the king schema, for the traces, it is just a block number plus block hash and the trace tab. And for the nonce, it is used to, the king schema is the transaction sender's address plus its nonce. And the value is just ILP encoded data. So the implementation is very small, very simple. And for trace tapers, currently we support the code tracer and other traces such as the parity trace and the preset tracer. Here is the workflow of the indexing, and for each block, we will index each transaction based on the TSA starter hook, and in that hook, we will to see if we enable the nonce tracing. If so, we first store the nonce traces in the KVDB, and if not, we just continue. And for each transaction end, we get the transaction result in our local trace, in our local cache. And when the block is ended, we will store the block traces into the KVDB. And in the meantime, we will notify our other background freezer to notify him we have just indexed a new block. And the freezer will freeze the newly created traces into RDB for the efficiency. And so this is just for the indexing, and let's see how can we retrieve those data. For the traces, we can retrieve it by the block number and the block hash. And for the transaction hashes, for the transitions, we can fetch the block first by the transaction hash, and then retrieve it by the block number and fetch the transaction hashes data by its index. And for the nonce, it's really simple. We can just retrieve it by the sender's address and nonce. And here is just a small workflow of the block traces retrieve index. Yeah, it's really, it's very simple. Just read the block number first and check the block data is whether in the KVDB or in the FlexDB, and then return back to the column. So how can I use this feature? As currently, this feature is not merged into the mainnet, into a master branch. So if you are interested, you can follow this PR and see how to use it. The left side is the configuration of the to enable the feature. You just need to add something like that in the left side. And on the right side, I will introduce every configuration. The first one path is just a dictionary which is used to store source data. And the second one, enable NAS traces, is index the left trace whether to enable the NAS trace or not. And the third one, must keep blocks, is just a block limit. So after such blocks, we will put all the data just to save disk size. And for the config, it's a map. It's a map to configure each tracer. And for each details, you can refer to the built-in guesses built-in traces for more detail. Okay. Currently, we support those RPCs. It's like the PeerDAS trace RPC, and the last one is the RPC. This is just a proposal, and it is not enabled for other clients, I think. Besides of the PeerDAS code tracer, we can also retrieve other guesses native traces. I think it is really useful when you want to get the history data or history plus data for one transaction or one block. We can just like this just RPC. In this example, we need to retrieve the plus data tracer for the block one. Yeah. So next we can just talk about the performance. Yeah. Before we talk about performance, in my mind, performance is just a space and time trade-offs. In this implementation, we just use the low-cost disk to store the data instead of the high usage of the CPU. So, for the advantage of the feature is just you no need to reapply the traces based on the data, and the time computation is very small. It's just O1, and the retrieving is real time. You can index in the data and then retrieve it back. And the disadvantage is you need another disk space to store those data, and it may have a little impact on the on-chain block syncing. Yeah. Here I just write some benchmark to compare the results of the trace RPC and the debug RPC. Yeah. It's a script to run to retrieve the data from the guess wise the JSON RPC, and this is a results of the JSON RPC results. The upper one is the traditional debug trace block, and the later one is the trace block. It is about 100 times faster than the traditional one. Yeah. That's all. Thank you.
Thank you very much. Your question?
Hey, thanks for this. Really appreciate it. I think as a developer, it's sometimes confusing because there's no standardization on the debug or trace namespaces, right? The other RPC methods are in the execution API, so they tend to be standardized across clients. When you move to debug tracing, it becomes a bit trickier. Other than performance, because some clients are going to implement debug, some implement trace namespace, some do both. Other than performance, like, why would you recommend trace over debug? Is there other reasons you would recommend that option for tracing?
It's more customized. You can just index the data by your need. Yeah, and because the traditional debug trace which is also only supported such as the parity trace, the code trace, and the flat code tracing. And if you want to index other things, you might need to write a JS tracer. And the performance is really very, some part is not very good. So in such a way, we just introduced the living tracing framework, and based on that, you can just write your own traces.
Right, thank you. I have another question unless someone else maybe.
Probably means that this will be integrated into Brock, or when it's going to be added together?
Actually, I'm not sure. Maybe this feature will be merged into the master branch and in the 4 or maybe when. No need to hard fork. Just attention.
Maybe can you touch real quick on the, you were talking about some potential issues on the syncing side. You had your second bullet point on the slide where you had pros and cons.
Sorry, I can't come back.
Do you remember? There was like 2 cons you mentioned. One was like additional storage space for trace was one of the disadvantages. And then the second one was, you said potential syncing issues. Can you touch on that or go a bit more and just explain what you meant by that? Or like at least, I guess, what you observed when you were benchmarking?
Actually, this is not inside the presentation, and I will attend it, and maybe in other works. Thank you.
Thanks.
Next.
So most of the speed improvement looks like it comes from caching and indexing the data. Did you look at indexing the built-in native debug trace?
You mean the debug trace?
Yeah, the pre-state and the call tracer, so that you're basically saying half of the argument is it's faster, but most of that I suspect comes from the fact that you're indexing all the data. Did you look at indexing the debug trace calls as well?
I'm sorry, I haven't fully answered that.
So most of the performance increase comes from
the transition reply.
No, oh really? Not from the index.
No,
not from indexing the data.
Actually, the performance is really depends on the history data. You need to feature all the history data. Need to replace the transition, so the performance is really because the disk feature is really slow. Sorry.
I guess, like, piggybacking on that question, like, the improvements that you shipped with Trace, the train namespace, could you not backport them to debug as well, or is that not possible?
Because in the left tracer, the data is just generated and stored on when the transaction is executed once. And when you use the debug tracer, the data is just replied when every time when you request it. So in this implementation, we just store it once and feature it at any time.
That's right, but you're talking specifically about the live tracing here, the real-time tracing, or you're also speaking about when you're, because when you had that graph that was showing 100 milliseconds for trace block, right? And then you had debug trace block at the top. That wasn't for live tracing, right? That was just historical calls or where you can trace any block, correct?
No. Actually, for the tracing, you need to index source data first. Just after the guess is started.
We gotta cut it off here. I'm sorry, guys. Thank you so much again for the presentation. Thank you for all the questions. I really appreciate the discussion, but we are running out of time. Many presentations, so we gotta move on. Sid, if you're ready. So yeah, thank you so much, JS Visa. It was great. It's another applause for JS Visa. Yeah, there we go. And yeah. And can I ask you guys for another set of slides? Yeah. Awesome. Yeah. Yeah, a lot of cool projects, a lot of great clients. And another one from Sid here. So Sid is one of those people who also have been part of the study group in the beginning and actually has been working on this since the beginning of the year almost, since like February. Because the study group introducing the Ethereum protocol starts with the introduction to the execution layer, right? And that's where we started, and that's where Sid still is, basically. He didn't move on from that, and he's been working on the C# Nethermind EVM implementation, so I'm very curious about your work. Yeah, go ahead, man. Cheers. This is next? This is before, yeah. Sid, everyone.
Hi, everyone. Right, so this is my project, EPF Nethermind EVM. EVM is an EVM optimization project from Nethermind in C#. This is sort of the loose timeline of the project. So week 6 and 8 was sort of done on some warm-up tasks to kind of get a feel of the code base. Week 9 and 12 was spent on doing some research for the upcoming task, which was basically gathering n-gram stats. The core focus of the project was doing the stat analyzer implementation, which happened between week 13 and 16. And then week 17 and 18, I was basically running the stat analyzer, getting the n-grams, and then actually doing the n-gram implementations for pattern detection mode for the EVM. And week 19 plus, I was just basically doing bug fixing and also just generally looking at EVM and bugs, and I found like 5 opcodes that had problems, and I fixed those. So the first part was basically it was my first task. I just joined EVM. I just started the project, and I think it was the first meeting with the mentor, and I basically was, the mentor asked me, do you know where I was? Because the mentor was sort of focusing on EOF implementation, so nobody was working on EVM. I just sort of took the task that was sort of remaining, and I started working on it, and then my mentor joined in, and that was sort of finished. The next task that I did was some CodeDB stats. Again, this is a warm-up task, where I just tried to get some n-gram stats from the database. So these are not execution stats. The implementation was very slow. It was done over the weekend. Again, it was a warm-up task. So now we kind of come to the, this is the research and algorithm. So there was a lot of research and literature review that was done for basically big data analysis, because we are dealing with execution stats for n-grams, which is actually like a lot of data. And these were some of the papers that were run, that I read. Of note are basically the heavy keepers and also sliding sketches in time zones for data stream processing, because these are both single pass algorithms. Because we wanted to implement an algorithm that is single pass for this amount of data and is efficient. So after a while, we just sort of, with some discussions with the mentors, we just settled on simple count-min sketch. The basic principle of the count-min sketch is that you have sort of D hash functions, and then you have like, let's say, W buckets, and whenever an item comes that gets hashed, and it's put into one of these buckets. So for example, here you can see just data for one item. So in this case, the true count will be the lowest count, that is 1. 25 would be an overestimation, that means there's a collision. So, but because we have many hash functions, if you take just the minimum of the count, you can actually get the true count adjusted with errors, etc., for the data that we need. So, additionally, you have these bounds of epsilon and delta that control the probability and the error that the data structure has, and you can actually configure the stats analyzer to use both width, depth, epsilon, and delta. So now for the main thing, which is building the stat analyzer. Okay, the first part was encoding the n-grams. So to encode the task was given is that basically we just need to find 2 to 7 opcode patterns, like 2 to 7, the size of the n-gram is 2 to 7, and the way to basically do it, and this could work for like up to n n-grams actually. It's only limited by the data type. You have like used one of the data types that is common in clients is like you have a 32-byte data type like UN256. So technically it could go up to like, I don't know, 32 opcodes. What we can do is we just get the n-gram, the long value that we have. We find the n-gram that is the maximum And then we can actually select that out, and basically if you have like an n-gram like pop add data, you can actually just iterate saved anywhere. And they just basically, you have these sort of ephemeral new sketches provisioned based on what our error threshold is, like what is the max error we're able to tolerate. So we can configure that, and then new sketches are provisioned based on that. It provides the top K patterns and provides the error and confidence for the stats. So you can actually have varied performances for this, so you can actually make it really fast and less accurate, or slower and more accurate. You have that capability. Right, so then how do we gather the data? The data is done as a trace. It's a trace plugin. It's straight from the EVM. You can configure this to be enabled or disabled. The tracer then finally dumps the data. It calls stats analyzer, and then it can dump the data into a file as a trace on the file. So how does that look? This is sort of the output. You can see initial block number, current block number, error per item, confidence, and these are the stats, for example. You have the pattern, you have the bytes that it is, and then you have the count that you've observed. And you can go on, you can specify how many you want. To give an idea of the configuration, that you can see all these are like, this is the config that you can do. You have enabled the file to write to. The write frequency is like how many blocks you want to write this to. Ignore set, like you want to ignore jump destination. That's not really useful for analysis, so you can actually write ignore set. You have an instruction queue size. The size of the queue is to gather instructions per block, right? Because that's, again, it can increase as time goes, so you want that to be configurable. You have the processing queue size. How many blocks are now, are stored for processing. You have the number of buckets that you can put in the sketch. You have the number of hash functions that you can put in the sketch. You can put the max error that you're willing to tolerate on the CM sketch. You have the sketch minimum confidence that you want to tolerate. You can analyze the top n-grams to track, like 10,000, 100,000. You can put analyze a min support threshold. This is sort of like a filter. Both of these, analyzer capacity and threshold. Then you have the sketch buffer size, and you have the sketch reset and reuse threshold, which is like where it gets provisioned a new sketch for based on error. So that's the plugin config. The next section was pattern discovery, selection, and implementation. So, right. So, wait. Right, so I used the stat analyzer. I did 2 sets. One was top 10 patterns of size 2, and that got merged. Then I did 11 patterns of 5 to 8 opcodes that's still under review, but this is basically in the pattern matching mode of EVM. So the opcode implementation has to be in parity with the EVM implementation. But you have certain opportunities of optimizing because you have a few patterns together. But the major optimization will come in the IL implementation because we have 2 implementations to do. One is the pattern matching and the IL implementations. The last was testing. That was just started like a week back, so it's still like very much a work in progress. So this involved testing IL, testing the pattern implementations, also the IL implementations, and the way we were doing this was basically we have 2 chains, and we have an enhanced chain where we enable the IL EVM and a normal chain where we don't, and then we compare the state root, right? But doing that also there are caveats, because what if there's an out of gas error? Well, both those chains would be the same. What if there's a, the spec is not enabled? Again, you'll get the state root passing the comparison. Invalid jump destination. So all these situations were there where it would just pass the test, but it's like the implementation is incorrect. So it's quite hard to test this. So anyway, so there was some detection that happened over the weekend. I think 5 opcodes that I fixed while testing, and testing for the analyzer opcodes and patterns is still work in progress. And well, thanks to all these, I mean, my main mentors were Shimon and Ayman. And a big thank you to Lukash, Ben Adams, Damien, for being sort of weekly there in the EVM calls, and Marek and Thomas for actually enabling at the beginning to help me meet all my mentors and setting the meetings up. So yeah. Thanks.
Thank you so much. Lovely. Thank you. Yeah, so it's very hard to fit all that work into a few minutes presentation, but we still have some minutes to go for questions. So anyone want to ask a question about ILVM in C# in Nethermind? Any question for Sid? Yeah, you're good? Okay, go for you're free to, you're chill. Okay, another applause, please. Thank you so much, Sid. Awesome. And next up is Derek. So if you can come to get ready. So yeah, thank you so much, Sid. And the next up, another presentation by Derek. And yeah, my honor to welcome Derek here, another of our fellows who's been working on Portal client implementation in. You got the music? Oh, no, we don't. Okay, that's good. Good for us. Yeah, so Samba, Java implementation of Portal, and actually Derek has been working on this also with Meltson, who independently, these guys started independently working on a similar thing, and then ended up merging their efforts. So I'm really glad. Oh, now is the music, or no? Okay. Anyway, yeah. So they managed to create a new Portal network client implemented in Java, so Portal, which becomes a very important piece of the protocol with 4.4s coming soon. Yeah, it's really amazing to see that you've been able to take such a big effort and start a serious project. So Derek, please go ahead. Yeah.
Yes, thank you. All right. Yes. So I am Derek. Unfortunately, my partner Meltson wasn't able to make it. But yeah, our project, our joint project is Besu Portal client, Samba. So yes, so I guess I'll give a brief introduction to Portal, because I think a lot of the reasons that I wanted to work on this project were just because I found Portal to be such an interesting topic. And so, oh, there we go. So for the purposes of Samba up to the scope of EPF, which is just for a few main roles through the history subnetwork, Portal Network provides a solution to the proposed changes in EIP 4.4s. That allows for the drastic limiting of storage requirements to run a node. As well, it also provides a way to handle the sharing of data in a way that not only can handle scaling, but actually benefits from scaling. And these benefits also directly link to Ethereum usability and the lowering the barrier of entry to participation in the Ethereum ecosystem. And then as well, outside of the scope of EPF, as we continue, Portal also contains proposed solutions to managing state and beacon chain-related information, though this is somewhat more preliminary. Oh, there we go. And so now moving into the role of Samba in Portal. There we go. So there's kind of two main roles Samba can play in this big kind of puzzle. And so one of the big roles is, of course, to fill the gap in the consensus Hyperledger ecosystem in terms of a long-term EIP 4.4 solution. In regard to the existence of Samba, this also works to increase the Portal client diversity, in addition to ease of use in terms of the Besu execution clients. But I think the other one, and potentially more exciting in my eyes, is its unique position compared to other Portal clients in that it has a way to easily bring Portal functionality to different the Android ecosystem, with the benefit of the inherent modularity of Java, but also its native support. And so it's a very realistic goal to expect that Samba could simply be built on top of as a library for other mobile or resource-constrained applications. And so moving into where Samba is at right now, my initial proposal at the beginning, it was extremely ambitious, and I admit that obviously not quite where we got to, but essentially this proposal is a model of where Samba will be at one point. And so all communications and related infrastructure, including disk V5, portal wire, and UTP, are eventually going to be implemented. Mainly UTP at this point is the one that we're working on. And then to have a fully functioning history network, as well as full function of state and beacon to the point of present portal development, as well as full interoperability with other portal clients. And so our updated goal range, of course, for the scope of EPF up to this point just pertains to what we figured would be reasonable in this time scope. But essentially that's to have had primary communication infrastructure, including a Discovery v5 and then the portal wire. Unfortunately, UTP was a big setback in the sense that there is no generalized UTP library, and so unfortunately we weren't able to piggyback off of anything like that, and will have to be something that we sit down and do ourselves. And then to have infrastructure in place for his history network function. And so then moving on, once we have that infrastructure and that we have is to have generalized internal testing. We wanted to have SSD serialization, deserialization, exposed API infrastructure, metrics. And the only thing on the list that we weren't quite able to achieve in this goal range is portal hive testing. Unfortunately, just given the scope, we're very close to having had it. A lot of it was just putting little pieces together to test it, but we figured it'd be better to just add more functionality before we go and add some just small pieces of testing, as opposed to now we can, as we go forward, add a lot more tests and then prove that we can then interop with other clients. And so this is a general diagram of kind of how Samba functions and the layout of Samba. And the big two pieces on the bottom here are the ones that really took the brunt of the time, is getting all the base protocol communication systems in place. And so that includes like inbound, outbound communication, whether that be coming from a client. There's a different way to handle requests coming in as opposed to sending out requests, or then receiving inbound requests or responses, and vice versa. But then, of course, there's other pieces of the puzzle, such as the API, which Meltsun had done and exposed an API. So we're very well set up to then start actually serving different pieces, such as the disk v5 and history, portal history APIs. And so moving forward in the project, the future of Samba, obviously the development of Samba does not stop with EPF. The project is in a very good place infrastructure-wise and has achieved a lot of milestones in terms of functionality. Like at this point currently, we are able to send and receive all different types, all the available portal wire packets to all the other portal clients. And in terms of certain packet types, such as ping pong, obviously work well. And then we are able to now, up to this point, almost full functionality on just sending and receiving nodes in terms of building our peers. And so moving forward, then the continued development will eventually bring us up to date with the other portal clients. And so that is, to me, also an exciting part of being a part of Portal, is that for the development of Samba, we have EPF, but then also after moving after EPF, there's a portion of getting fully caught up to other Portal clients. But then in terms of, I guess, my experience, it's also very exciting in that once we get to that point, it's an entirely different development paradigm, where instead of catching up and following different specs, it's now actively participating in development. And so this development is much more something that I will have to learn as well, and that kind of brings me to, I would like to talk a bit about my EPF experience, because I think that was a really big part of this program for me, is just a lot of the learning that I've done. And so I think for me, there's definitely too many skills to list here. But if I were to sum it up, EPF was my introduction to Ethereum. Before EPF, I didn't know what Ethereum was. I didn't even know what blockchain technology was. So for me, that was a huge, just to get into the space and learn everything. And of course, that brought a huge confidence boost in terms of development. I previously, I've never worked on such a large scale project before. And so those organizational skills required to create that project was like huge to me, and definitely gives me a lot more confidence moving forward and in terms of developing projects and continuing to work on this project. As well, I think I acquired a lot of new learning skills for me, I think I could best describe it as I learned how to learn. So I guess the biggest example in my case is going through and learning the consensus discovery v5 library. I had never had such a large-scale library that I had to learn in the past, and so learning this library and then automatically going over to the Teku library and then learning the SSC internal infrastructure was a way to then quickly apply the skills that I just learned to then learn a new library, which was a really great experience. And then as well, it gave me a project I really enjoy working on, and of course will continue working on. And so yeah, the Samba repository can be found on Melton's GitHub. I hope that one day we can have a Hyperledger or consensus repository for that name. And then, of course, I'd like to give a big thank you to Melton. Unfortunately, he wasn't able to be here, but it's been a great partner, great working with you, Melton, if you're watching. And then my friend and mentor, Colby. So, unfortunately, I can't say that to Colby. If you're interested more in Portal, his talk is going on, I believe, on stage 2 right now. And then, of course, EPF organizers, Josh and Mario. It's been a really great experience. I really thank you for this. But yeah, thank you.
Yeah, thank you so much, Derek. Yeah, really appreciate it. Really appreciate your words and also your experience with EPF. That's amazing to see. And yeah, I'm also couldn't make it. I met him in Argentina like a week ago, and like he's also a great person. Couldn't come, but he will be still also contributing to Samba. Anyone has a question about Portal, about the best with Java implementation? Yeah.
Responses are functioning, and then as well exposing APIs. A lot of the stuff also just includes serving like information that comes just from the Discovery v5 library, and so that's kind of the part that we are now stepping into, is getting all that set up.
Cool. Thank you so much. We have a space for another question if there is anyone, any comments, any questions. Yeah. I mean, it's very important topic. In the L1 clients, we need diversity in the Portal clients. So yeah, I really respect the work, man. And if there are no to hold it straight so we can hear you, because it's too far. Yeah, I just want to. You need to plug it to your computer, so because it's from your computer, so it needs to be plugged in. Yeah. Right up. What the hell? I don't know about MacBook. Maybe just turn this off and it should work. No, it should just work. It's just come on. Do you know how to stop clicker on MacBook? Clicker on MacBook, man. It asks for some. There was it asked you for the. There was a prompt. No, you plug it in and there was a prompt that you need to set it up. Can you open there was another window which asked you for the prompt. You minimized it on this screen, on the screen of presentation. There, this screen in the middle, there was, can you see all the windows, please? There was a window which asked you for like setting up a clicker. Or you can just use the computer. If we don't have the clicker, it's okay, we should start. Yeah, just use the yeah, that works. So just okay. Sorry, just clicker drama again, like technology, right? So we have Aditya next. Thank you so much for being here. And my honor to welcome Aditya here, because he's been working on very important project as well on Verkle implementation in Red, which is like incredible piece of work as well. Like he taken this upon himself to start working on the vector commitment Merkle trees in Red client. So now Red is very open to contributors. That some such an important feature is done by some random contributor, basically, right? So first they were like hesitant to look into it and like wanted to rebuild it themselves. But then when they actually saw the code, they accepted it and gave feedback and started to work with Aditya. So it was a bit of a drama there to actually get it merged. But I think it's amazing that we managed to make such a significant contribution to one of the execution clients. So great job, Aditya, and I'm looking forward to the presentation. Yeah, the stage is yours.
Thank you, everyone. Hey, so I'm Aditya. I worked on the project of Verkle tree integration in the Reth. Basically, the code involved the modification in the Reth to enable the stateless mode. So before moving forward, I would like to discuss a few points about the Verge and the Verkle trees. So the main goal of the Verge was earlier to enable the stateless client in Ethereum blockchain. But now the Verge represents a very ambitious and a bigger goal to verify the whole consensus and execution using snarks. But currently the stateless team is focusing on enabling the Verkle trees in the execution clients. So my project involved only implementing the stateless mode using the Verkle trees. So the stateless mode first can also be enabled using the Merkle-Patricia trees, but the witness size are very big using the MPTs. In average case, it's about 3 KB, and in worst case, it might rise to about 3 times faster. So the concept of Verkle trees was introduced. The main feature and the main advantage of the Verkle tree was to reduce the size of the witness. And it will be used as a major state commitment tree in the stateless mode whenever the Verge is activated. So yeah. So now moving forward, what were the changes I implemented in Reth? So actually, the changes can be divided into 2 parts because the DevNet 7, which was launched about a week ago, it is a DevNet used for the Verkle testing by all the clients, such as the Nethermind, Get, Red, and every other execution layer clients. So this DevNet targeted actually 2 EIPs. The first one was 4762, which it was related to gas cost changes, and the second one was 6800. It was basically related to the trie structure. So the first modification were related to the EIP 6800, which were involving the trie structure modifications. So the main change here was that in the MPTs, we basically maintained 2 structures. One is for account tree, and the second is for storage tree. But in the Verkle world, there will only be a single tree structure. It will be handling the commitment of all the storage, of the storage, as well as the account data, which involves the code. Example, if you want to access account data, you will be using a zero value, which is suffixed to the original key and encoded for the final key value. And similarly for code value and the storage value. So now, instead of using the 2 separate versions of tree, we will be using a single Verkle tree for managing the state. Now, what were the changes actually needed to implement this? First of all, the Reth, the Reth actually uses the after every transaction in the block, intermediate state root was computed, and after block finalization, when the final state root after the block was computed, were replaced by a Verkle root provider, and the Verkle root provider were now handling the commitment process in the Reth. Now, there are some improvement in the efficiency and the processing of the clients. For example, currently the MPTs implemented by Reth uses caching mechanism for storing the intermediate roots. They use incremental updates so that they do not have to compute the whole root again, and they can just partially compute the roots. And the third one was parallelization. So Reth has enabled the account tree parallelization. The model is currently working fine. One of the major changes that was introduced were in the database structure. For example, earlier there were 2 tables maintained. One was for the storage and one was for the account. But now there is only one Verkle tree structure which needs to be maintained, which is responsible for handling all the state commitments. So these changes were related to EIP 6800. Basically, the root, the trie structures and the commitment structure in the clients. So next major EIP, which was targeted by the DevNet 7, was 4762. 4762 is basically the modification done to the EVM for when the witness is constructed, all the gas cost changes were needed to be implemented in EVM because now construction of witness were included in the block production, and all these accesses will require extra cost for accessing the various data required for witness construction. So basically, the EIP targeted two types. One was for access event and second was for write events. The access were basically reading the data for constructing the witness, and write was for writing the data while constructing the witness, right? So you can see all the opcodes that whose gas cost will be modified when this EIP will go live. All these opcodes were need to be, the gas cost model for these opcodes were modified. Yeah, and this EIP also designs how we are going to access the pre-compiles, the system contracts, and the gas cost of various opcodes. So how I implemented in it REVM. So I referenced the implementation of get and Nethermind for this purpose. These are all the functions that were called whenever a particular opcode is executed during a transaction. These functions will be called by these opcodes. They will be adding the cost for witness access during the execution. The main logic was the access key function, which is internally called by all of these functions. Access key function is basically responsible for basically charging all the gas costs. It checks whether it's for access, whether it's for write. It maintains a list of all the access subtrees and modified trees. It charges accordingly. If the tree is not yet touched, it charges the read cost. If it's already touched, then it will be charging the write cost. So all these functions were separately implemented, and they were inserted wherever the opcodes for that particular function called. Now, the most important part of the project were the test vectors. So test vector, basically the execution spec test, which is developed by the stateless team right now. So they are the major, the project. Even though all the changes were implemented, but these test vectors, they currently consist of more than 100 tests, about I guess 200 maybe. So this test vector actually not only judges the code, but also they are responsible for handling the various minute cases and the edge cases of the clients. So after I was able to pass about 60% of this test vector, but there were some edge cases. For example, you don't have enough gas for adding the data to the witness, but still you are adding it because they were supposed to be added during the propagation. So that edge cases need to be encountered here. So some of the tests are still yet failing, but I will be altering the code accordingly. So 4762 and 6800, there is a third EIP as well, 7709. This EIP I am yet to touch. It is basically handling the block hash instruction. The plan ahead. So basically, I was able to implement all these EIP, and about 60% of the test vectors were passed. But the goal I set was very ambitious. Basically, this work is going on for almost 1.5 to 2 years. So implementing all this thing in 3 to 4 months were like a hectic task. But I'm like really proud of the work which I have done till now. So basic modification for commitments are done, for REVM changes are done, and the try changes are also done. The next phase will be, for example, what I want to say is like the main things such as the construction of witness, propagation of the witness are completed. But the main feature of the stateless execution was the stateless mode, where the block will be executed using the witness, which is provided using the along with the block and not with the existing state with the local client. So stateless execution uses witness is the next main feature. This feature is not yet implemented by Get because it's not targeted for this DevNet, but it is live in the Nethermind, so I will be referencing the Nethermind's implementation for this stateless mode. Now, more into the future, the Verkle not only involves the try design and the gas cost changes for storage, but the main problem the Verkle world will be facing will the sync design, how we will be moving from the Merkle Patricia trees to the Verkle trees, how the data will be migrated. There are some existing strategies for this. For example, the overlay root strategy, which is currently accepted, and there are some syncing strategies as well. For example, it's implemented in Nethermind, but the research is yet to be done for these purposes. So syncing would be the next phase for the Verkle research and the main target for the stateless team. Apart from that, the recent ZK technology have evolved a lot. There are some improvements in the proving technology. So even though there are many advantages of the Verkle, for example, the witness is updatable in the Verkle, the proof size are very small, and the Verkle code is almost ready for the production, we can shift to statelessness directly. But there are some research going on to directly shift to the whole verification of the consensus and execution layer using ZK snarks. For that, the Verkle is very not easily used. We are not able to prove the Verkle trie structure easily using snarks. So there are some proposed structures such as starked binary hash trees and circle starks and proving hashes using circle starks such as Poseidon and everything. So the main task will be of the stateless team will be to go through a tri-agnostic design. So whatever will be the tri design accepted finally, the main changes related to gas cost, syncing, and witness construction should remain same. So this will be my major task. I will be running syncing with the stateless team and carrying out the work for the RETH on behalf of them. Final note, EPF was a very great experience for me. I would like to thank Josh and Mario for giving me this opportunity. This was the first major project which I took apart from my personal contribution. So this provided a very good direction for my future developments. I would also like to thank Kev on already implemented the Rust Verkle tree structure, which I used for modifications in the RETH. I would like to thank Ignacio from the Get team and Tanish from the Nethermind team as well, and Oliver from the RETH team for mentoring me through this project. So, like, EPF is one of the best gateway for Ethereum core protocol development, and if you are getting a chance, you should go for it. Yeah. So thank you, everyone. This was my project.
Awesome. Thank you so much for your kind words. Thank you so much, Aditya. I appreciate it. And we have a space for a question. If there is maybe like one, two questions. Anyone? Any comments? Yeah. Oh, there is one online. Are you also going to implement the state tree migration approaches, like the overlay tree?
Yeah. So the migration strategy is not yet finalized. Overlay tree, the design of the overlay tree is not much clear right now. Like it is not at all implemented in any client because research is also not going into that because we the main target is to first get over with the gas cost changes because we are the team is planning to make live the gas cost changes before the merge because then the other L2s and should get accustomed to the various gas cost changes. But the transition and the sync is not yet designed completely and it's very vague right now. So I will be running interop with the stateless team, and whenever it will be ready, I will be more than happy to implement it.
Yeah, awesome. Thank you so much. Yeah, thank you so much, Aditya. Amazing. Yeah, very well. Yeah, the migration is still kind of out in there, so it's gonna be future effort. We have Vricha next, if you're ready. Do you have HDMI? You plug in.
Hi. I have a question.
For Aditya, yeah, okay.
Yeah, so I think RETH has a similar database design as Aragon, which is path-based. So, like, while you were implementing like the Verkle trie in RETH, did you have to like modify or like optimize in any way the path-based?
So the same database structure is in the Aragon 2, not in the Aragon 3.
Okay.
And this thing is everything, not like mostly nothing is implemented in Aragon 2 and Som from the Aragon 3 team is using Aragon 3 for this, and Aragon 3 does not share a database structure with the RETH. So with the path-based structure, I did not modify anything to the path-based structure. I just introduced a different table for it for storing the Verkle tree for the state commitments. So yeah.
Did you run any numbers?
Yeah, so I haven't tested my database right now, but I will be getting the pre-images from the Aragon because they are able to supply right now,
Okay.
and I will be benchmarking the performance using the pre-images and the mainnet blocks.
Okay.
Thank you so much. Yeah, thank you so much for extra question. We gotta switch to Richa, and I'm sorry the clicker doesn't work. So yeah, just like Aditya, just please use your keyboard. It's gonna work. Use your keyboard and here's your mic, and please just hold it close. Yeah, thanks so much. Okay, our next speaker, Richa, and again, it's my honor to welcome another very successful, very talented fellow on the stage here today. And Richa, because she didn't work on only a single project, she took upon a lot of work during this fellowship, and this is just her first presentation today. And it's, do we have, yeah, the HDMI? Yeah, the video, very well. Yeah, so Richa also contributed to the Verkle efforts by creating C bindings for the Constantine cryptographic library. And yeah, the stage is yours. Please go ahead. It's your laptop, but you need to change. I don't know how you do it in MacBook. Perhaps. Do you notice how on like developer and technical conferences all the tech just fails? Yeah. It's like the hacker conferences, right? Yeah, we just need to change the display. Oh, yeah, sharing.
So hi everyone, this is my project for implementing C bindings for Verkle IPA. So yeah, I was mentored by Prysm from Constantine and Agnish from Nimbus team for the project. So yeah, talking about the project, how it all started, like I started on the project pretty late last month. So basically, the idea behind the project was the Constantine library provides a lot of cryptography primitives for Ethereum and non-Ethereum backends. So yeah, so the project basically was developed since there was provided by the Constantine, and the Nimbus implementation of the Verkle drive was significantly good. So yeah, so that's why the way to use the Constantine library for integrating with other clients was to export the Verkle IPA implementation using the C bindings, and this is what the project was about. So how it all started was, so the first step was implementing the bindings for the Edwards curves and the Van der Wagen curves along with their operations. So yeah, this basically involved, since the Constantine library already had implementation of Van der Wagen and the twisted Edward curves, but they were not exported through the C bindings. They have C bindings for some of the curves, like the elliptic curves or other Pallas and Vestas curve, but the Edwards curve and the Van der Wagen curves were missing. So the first part of the project was implementing the C bindings for these curves, and then since the Constantine code base is basically generic, like it is not protocol is specific to Ethereum, so the next step was to implement the Ethereum specific wrapper for the Verkle IPA implementation, and then exporting that to be available to other clients. And next was to integrate it with the client teams. So presently, I was involved in working alongside with the Besu team for integrating the Constantine bindings in their Besu native. So yeah, so how it went, so I started with implementing the bindings for twisted Edward curves. So this involved all the operations they had, like the addition, multiplication, scalar multiplications, batch affine, and so the mainly the curves which were used for the Verkle here were affine and projective, and all the operations which were yeah, and the operations for these were basically needed to be exported. So the bindings were generated for the affine and projective curves, and then implementation of the Van der Wagen curve was also done in a similar way, where they had the scalar field and scalar field implementation, scalar field specific operations exported through the C bindings. So this first step was completed and was approved to be merged and here's the PR for it. But there were some issues since Constantine is still not ARM compatible. So there were some issues which I was facing while working on like proceeding further with it, as there were some GMP headers which were not being able to, the Mac was not being able to find it. So like had to work on it with the Linux systems. So the next phase was to implement the generic, to make the Ethereum specific bindings for the Constantine code for Verkle IPA. So yeah, so this involved basically implementing the functions which were needed for to be integrated in the client architecture. So it was the proof, multi-proof, commit, and verify and multi-verify. So yeah, and exporting these through the export C pragma. So this PR is, so like this work is also done and it is open for review. Talking about how the next steps will go on. So yeah, there are a lot of problems which are rising due to the ARM incompatibility with the Constantine. So first, like we need to figure out if there is some way so that we can proceed on with the testings, and then test the C bindings with the test the C bindings for the curves and the Verkle IPA from the Constantine, and then finally integrating it with the client teams. So we have a Besu team with which the work is currently going. So there is a PR on which the work has started, but since the bindings were missing, so we need to implement, integrate it with that. And yeah, so this was all about.
Thank you very much, Richa. Thank you so much. Yeah. Any questions? Any comments for Richa? We have a ton of time to, yeah.
What problems are we're facing with the ARM specific? Is it code, or why specifically is there an ARM problem?
Oh, so there were some. There is a library GMP which is available in the C. So that requires the x86 architecture. So the linker, when I'm using it in the ARM architecture, the linker is not able to find the path. So I tried several ways, like including the exact path for the GMP, because GMP is in the system. So I tried including the exact path, and several other ways, like manually trying the linker to link to that GMP, but that didn't work yet. So I have to find other ways to see it.
Nice work.
Thank you.
Awesome. Any more questions? We still have a space. If there is any question, comment for Richa. Yeah. Yeah.
I just want to test them. Yeah. I was just wondering, can you say like what went really well with this project, just in general?
Sorry?
What went really well?
So what went really well was, like basically I got to know about the Constantine library. Like on my part, like for the learning was the mainly thing which I actually enjoyed on. And apart from that, while working on the bindings, like the Verkle try was already implemented, so exporting those bindings were quite easier, because the bindings, like generating bindings, there was already a template which could be used directly to have the data types or the curves or the Van der Wagen or the associated parts to be integrated. And there were several segments of the code which needed to be modified because the library has a lot of links internally. So that was also easier because of the way the code is.
Awesome. Thank you so much again. Yeah, give it up for Richa again. Thank you very much. Yeah, that was lovely. Yeah, and again, it's not the last time you see Richa on the stage here today, so let me unplug you. Yeah, there we go. Next up is Lea. Yeah, if you're ready. Also plugging in. we have another lady fellow on the stage today, and actually similar story to Richa, because Lea was also working on multiple projects, and to be frank, Lea took quite a big bite of the core protocol contributions, because it was a lot of work to do, and although she wasn't able to finish all of it, she still made a great contribution, and today she will talk about the HTTP client implementation in Lighthouse and her contributions to it. So yeah, the stage is yours.
Thanks, Mario. And so I'm Leah, software engineer, specialized in Rust, and...
You need to switch your slides here, yeah.
Okay.
Wait, no, you need to, yeah.
Oh.
Oh, but this thing.
No, you need to... I think I need to... not this. Oh, okay. I mean, I can duplicate otherwise. Yeah, thanks for being here. So I'm a software engineer specialized in Rust, and as Mario mentioned, this project was in fact supposed to be a 1 week's maximum good first issue to start it in Lighthouse, and not my initial project. But as we are all developers, and I think one of our defaults is like to underestimate development time. So I picked this project, of course, to go deep into Lighthouse and understand better before transitioning to a more research project. But as a developer, always interested in big refactor. So why do the team wants to move between Warp and Axiom? But first, what is Warp and what are Axiom? So there are web server framework creates in Rust, and one has been developed a bit long time ago, so it's a bit low level oriented and a bit less easy to use, despite Axiom has been developed by the Tokyo team, Tokyo organizations, and a bit easy to use. And why do they want to move? Of course, they want to move for easier of use, and because Warp types, which is very focused on filter queries, is a bit difficult to handle. And also, it's very, something you need to understand is like only one part is still using Warp in Lighthouse, and all the other parts are using Axiom. So the idea, of course, is to unify, but one also important things in Lighthouse right now, they want to have this modular approach, so they will size the opportunity with this refactor to have a more for all the different Beacon API endpoints to refactor the function handler, and then it will be easy to integrate in a new repository called Ethereum API, where you can have a special trait Beacon API and just referencing to this Lighthouse new endpoint handler. Just to mention, this is the most sexy slide I've been doing in my consultant career before. Just to mention, as I've been saying, only the Beacon Node API is targeting in this project. Previous one, other parts are already Axiom oriented. So refactor challenge. First intuition is like to remove completely the previous create Warp, just to replace by Axiom and to find equivalent. But it was definitely not a good idea because we wanted a performance test before and to have a more soft-sort approach and just say, oh, okay, I want to use this new crate, let's replace and not have any metrics about it. So very simple condition first to test the different implementations. Something I didn't mention that the work was already initialized by the Lighthouse core developer, and so we could already test very simple endpoint that has been refactored in Lighthouse. So we could do just performance testing and have tests by targeting with a certain number of requests and check and compare the difference performance time between Axiom and Warp endpoints. So the result that is Warp is faster than Axiom, and probably because if you have, most of the time, if you have also a crate that is easy to use, it means it can be more interface, and so it's most of the time a bit slower. Also something just by curiosity I was looking at is, it was that if the task spammer has an incident, of course it has one, but the difference is very, very important. So our idea right now is to refactor, to have a better handler on the task spammer. There are still a bit work to do to handle in a bit better way the task spammer in the Axiom refactor. So still a lot of steps to do. As I mentioned, I'm already working on it. There's this optimization of the task spammer, and I want, especially from tomorrow, have this great occasion to meet the Lighthouse team to define a very specific plan in the GitHub issue and have all this transition issue, and probably also any developer can take part of this transition. The more it is split, the more it is better for anyone to take in. And yeah, just to deliver the task after. And as I mentioned, if we are refactoring all this endpoint handler, after they can be referenced in this Ethereum API in the repository in the specific Beacon API trait. Yet, of course, ePF is not just about technical or Ethereum knowledge. Of course, it's maybe 90% what is targeting, but it's a lot of personal insights. As a developer, I could have a better vision how to have more manageable piece and do what I call baby step. When you are doing a big refactor, especially with Lighthouse, rate, a very huge repository, work is not finished, and there are maybe 80% still need to be done. But I still have a better overview about Lighthouse repository, especially this Beacon API, and smarter reflex as a developer. Thanks a lot to the EPF team for all the help, guidance, and to the Lighthouse also developer team. Thank you.
Awesome. Thank you very much, Leah.
And as I mentioned, so there is all this timeline, and as it is finished, I can really start the fossil implementation. Thank you.
Yeah, awesome. Thank you so much, Leah. Yeah, I appreciate it. Again, it's amazing to see that you still pulled through and managed to make it till today, folks. We have questions for Leah. We have a ton of time, so feel free to ask.
Did you consider any other web framework other than Axiom, like Rocket or anything which is?
So following that question, where did Tower feature into the conversations about this transition at all?
It was proposed as a project. Axum because it was already used.
I see. Okay.
To unify the stack. But I think they can answer also.
Yeah, if there is any Lighthouse inside as well, feel free to add a comment. Yeah, thank you so much. But if there are any more questions or comments, folks, yeah. Yeah, otherwise, thank you so much again, Leah. Yeah, I appreciate it. Thank you very much. Awesome. Awesome. And next up is Cyan, I believe. So let's take a minute to plug in again. Just so you know, this is all MacBooks having these issues, not Linux computers. And yeah, we're almost there. Just, yeah, drag the presentation. Awesome. Yeah, I think there is some night mode or something. Yeah, we just get the colors, right? And we're almost there. And let me meanwhile introduce Cyan, our another speaker, another successful fellow. Thank you so much for being here. Yeah, I think it's good. We can be a bit orange. Yeah, yeah. Thanks so much for being here, Cyan. Another fellow working on Lighthouse. Another fellow contributing to Lighthouse Consensus Client. This time integrating the logging framework tracing into Lighthouse. So thank you so much for being here. Yeah, go ahead.
Hello, everyone. So first of all, let me say this, that my project isn't that cool. It's kind of like tedious and large size chore. Like you guys will get to witness many cool projects. So I will just keep my presentation short and finish this quickly. Okay. So, okay, I'm Cyan, as you can see already. And I have been trying to integrate tracing into Lighthouse. So first of all, a little bit of background for those who are not familiar with the Rust ecosystem. So tracing, what's tracing? It's a cool async-friendly logging framework. And but why did we want to migrate Lighthouse from slog to tracing? Because slog is kind of lame, and we need to pass a logger everywhere while using slog. Slog is not async-friendly at all, and it makes exporting Lighthouse crates kind of annoying and pretty much painful. And on the other hand, we have tracing, which provides additional contextual info. That means we get a better debugging experience. We have modern logging tools, and it makes easier for external code consumers to export LH crates. And most of the dependencies in the Lighthouse already uses tracing, so we might as well do the shift. And it's it's quite async friendly as well. Yeah, just way better than slog, in my opinion. Okay, so what have I done so far? There's the PR. If you want to go check it out, you can just go to the Lighthouse repo. And in the PR section, you can sort it by the most commented PRs. And it's currently the most commented PR over in the Lighthouse. I'm not sure if it's a good thing or bad thing. not a great thing, I guess. But yeah. So far, I have migrated, like the PR isn't merged yet, but I have migrated the whole Lighthouse code base from slog to tracing. and I have almost messed with almost every file there was. And I re-implemented the custom formatter, and I re-implemented the SSL logging component, and also replaced the slogger, which was used for the file logging stuff, and converted it to, like, shifted it to rolling appender. Yeah, so let's move on to the next stuff. Yeah, so this is what the logs look like right now, and we try to make sure the format is almost exactly the same as we had before. So yeah, and next up, let's discuss some challenges. Okay, so one of the challenges that we faced was to keep the format same, because many external and internal infra depends on that. Depends on the log format to be the same. I just got to know that Siren kind of depends on the log format. So yeah, we just, that thing is before adding a custom tracing formatting layer, and this one's what we have now. Yeah, so we just try to make sure there isn't much difference. Yeah, and other thing was tracing doesn't have a crit macro inbuilt, so we had to implement it on our own. So here's what the crit looks like. And this was the trickiest part. So the previous implementation of SSL logging was kind of complex, at least for me, to understand. And shout out to Edge for helping me understand that code. So basically what it was doing was, they were using slog async. It collects all the logs into a single task, and then the task could then print and write to files asynchronously. And the HTTP API wasn't a separate task, so it couldn't see any of the logs. So they had to modify the slog async task thing to create a channel, and then HTTP API could just get this channel, and then the slog task could just dump all the logs into that channel. And for some reason, slog records didn't allow sending the data through the channel, so they had to make the async record thing. If you check it out, it's like complex, I'll say that, because I didn't understand what was going on, so no point in making comments. Okay, so with tracing, it was super easy to implement. We just had to set up a tracing subscriber, and it was almost done. And this is what the SSL logging looks like right now. And we had to just remove the whole SSL logging part from before and re-implement on our own. Okay, and other thing was span versus slogs O macro. So both of them are kind of used to get additional contextual info, although they work kind of differently. And thanks to Eitan for helping me out with this one, because the first thing I did was just I replaced all of the slog O macros wherever they're being used to span, which like it was functional but wasn't working as it should have. So here's both of those PR are from Eitan, and he managed to add the spans in the /s service and ETHRPC service. Yes, so and I'll also have to add a lot of spans. It's on the roadmap next, but yeah, they are just added so that we can get the service to show up in the logs, which is currently many of the services aren't showing up on the logs. So yeah, some just random challenges that we faced were we tried to break it up in multiple PRs, but it would have broken the SSL logging, so we had one single PR, and it has been quite a bit of back and forth. And last thing was severe skill issues, because I was really bad at Rust and development in general. So yeah. So next steps. Adding more spans, as I've said, that a bunch of services aren't showing up in the logs, so we'll need to add a bunch of more spans. And there are still a lot of feedback fix iterations left to do, and we'll need to do more QA and testing to make sure we don't break much stuff. Another thing was, yeah, we need to add some flags to enable or disable additional context. And overall experience was great. The APF last 5 months were went pretty well. Working with the Lighthouse team was great. Thanks to you guys for being here and attending the session. Bit better at Rust, I think it's debatable. So, and loved the office hours, got a lot of alpha from there. And finally, huge thanks to the Lighthouse team, especially Age, Etan, and Mac. And special thanks to Etan and Mac because they are dealing with that mess of a PR. Like there's all the comments and all the back and forth. Thanks for being so patient with me. Thanks to Age for helping me out with the SSE logging stuff. And thanks to Josh and Mario for conducting the whole EPF. And just thanks, guys. You guys are the OGs. So yeah, that's all. Thanks for sitting through my weird stuff, whatever that was.
Yeah, thank you very much, San, for your kind words, but please don't be so humble. I think you still did a great job. It was a learning experience. So, guys, I mean, I hope that it was productive, right? Come on, like, he helped you, right? So don't be so humble. It was great. Yeah, and now we are running ahead of time. We have, like, ton of time for questions. So please, like, yeah, give him the business. Give him some questions, comments. Anyone? Yeah?
So are you using or tracing traces between instances or a separate client and server? Are you setting remote parent IDs for traces, for analyzing them in, for example, Grafana Tempo or other?
Not yet.
Okay.
I haven't set up yet.
What are you using for analyzing logs?
I'm not sure if I'm using anything. There's a thing called Jaeger or something. I am not using that yet. So there's a lot of testing and QA and analyzing left.
So this is only file appender?
Yeah, file appender. We have SSE logging stuff working, and normal logs are showing up. Yeah.
Got it. So any plans for adding metrics layer? Like
yeah,
is
there's
very cool library.
Yeah, there's there's already the metrics layer that was already being used for the libptp and disk v5, but it's not functional yet because I messed up a lot of stuff. So once that's done, I'll make it functional. It's, if you see the code, there's the metrics layer added in the subscriber stuff, but it's not functional yet.
Did you see any memory improvements by removing there's like a global log?
Sorry?
Object. Did you see any memory improvements between?
I haven't checked.
You haven't
checked.
Any comments or questions? Yeah.
How do you choose which memes to put into your presentation?
I don't know. Most of the memes like I added last night, so whatever.
It's OC memes. It's you are the OC, right?
OC,
the
yeah,
original creator, yeah.
Yeah. Whatever.
That's great. Yeah, we still have time. If anybody, yeah.
That was a great talk. Could you share more about the fellowship application process and how you came to that opportunity?
Oh, okay. So I guess these two guys are the best guys to talk about this, but I had some friends who were fellows, so I got to know about the fellowship from them, and I did some contributions in the execution spec tests and like some of the clients, and before that I was doing some security research stuff. I don't know if that helped or not, and once the application opened up, I did it, and when the study group was starting out, I just like did a small typo fix. I'm not sure if that's the reason, because I got
Yeah, that's why we hired you, man. I mean, it was TDPR that comes. No. Yeah. Just to elaborate on it a bit, because thank you so much for asking for that. We are going to do the next cohort next year. Now we have kind of the regular schedule where we organize these cohorts June to November. So it's 5 months, starting in June with applications opening in May. But one important thing to mention here, that this program is fully open and fully permissionless. It's like, I believe that it became kind of the place to come to start contributing to core Ethereum, but still it's more of a like word of the mouth than general knowledge. So like please spread the word and invite other people who might be interested. We are also doing the study group, which is more like just learning process. There's a wiki that we collaborate to create, epf.wiki. All information is there about the study group and so on. Next year we are going to be iterating on it, improving it, adding more materials. And it's something for people to get ready for the fellowship, or just like those who are not ready yet, who don't have the developer background, Ethereum background, they can take like a month or two of the study group. I did for 2 months. They can study those parts they are interested in, and then it's much easier to start with the fellowship. Yeah. And again, like it's fully open, so even those people who are not submitting applications or don't get a stipend can still work. So a bunch of the people that you are going to hear today were not paid for this. We're just dedicated to Ethereum. We're so excited to work on this. We got them the trip to Bangkok to award them, but still, like, it's just pure dedication of many people. That's what I love about this community. Yeah. And again, thanks so much, Cyan. Yeah, great talk. Yeah, please don't be so humble. It was great. Yeah, and yeah, give it up one more time. Yeah, thank you so much. And next up is, I think, Richa again, maybe. No, Bustin. Sorry. Yeah, come, guys. Yeah, we have we have a few minutes to set up, so we're gonna have another 2 minutes break. We have these sessions back to back, but yeah, let's set it up. everyone, please take a seat because we are starting with another round of presentations. So, my honor to welcome more speakers on the stage here, Bastin and Rupam, with another presentation. I want to highlight that Bastin here, these folks have been working provisionally, as I mentioned before, and it's again huge thanks for your work, for your contributions, and making it all the way here. And their work is again important contribution, the Light client server in Prism. So yeah, important part of the stack for people who want to run Light clients. The stage is yours. Go ahead, guys. Yeah.
So, hey everyone, I'm Bastin.
Yeah, hey everyone, I'm Rupam, and we have been working on integrating Light client server-side support in Prism. And for the project intro, like Light nodes are basically nodes which you can run, which you use significantly less resources than a full node. But there are some drawbacks. How a Light client works is basically they maintain this chain of block headers until the latest block header. We get this trusted block route which is available in the network, and using that we can fetch a range of updates. After that we get the root hash which can basically be used to determine the latest block header. So there's this reference of the Light clients after the merge by Ethan. It was covered in Devcon 6, I guess. Yeah. So you can check it out. It's really nice. And yeah.
Yeah. So if we're looking at what a Light client update looks like, it's a simple structure. It contains the block header, so the Light client can basically save that block header. It has the current sync committee public keys. The sync committee is the 512 validators that sign each block header, and the Light clients basically verify that block header by checking the sync committee signature. And there's also something else called the sync committee bits, which shows which of these 512 validators actually did sign the block header. And also there is this next sync committee, which is the sync committee, the 512 sync committee for the next period. So you can basically check when you get the next block header that the signature checks out, and this is actually part of the chain. Yeah. So how the network works right now is that we have this beacon network, which full nodes talk to each other and connect to each other. And we have a Light node on the side, which basically asks one of the full nodes for these updates over and over again to be able to stay synced. And then we have this RPC provider that we might not trust. So what a Light node, what a Light client actually does is that it gets the data from that RPC, but instead of just trusting it, it checks it against the state route that it gets from the full nodes. Yeah. Yeah, and what we did in this project was basically implementing that part, which is how the Light node talks to a full node and gets those updates.
Yeah, and there are 4 endpoints. The first one, the bootstrap using the block route. You have the trusted block route in the network, and you can just call the bootstrap on that block route. And after that, next slide. Yeah, you get a range of 3 updates. Let's say 3 here. And when the Light client has synced up to the latest block header, you can just keep calling optimistic update or finality update according to your needs.
Yeah, so the project phases that we had was we got familiar with Prism and how Light clients work, and then we started implementing the specs and then going back and forth with testing and debugging. This is nice, but this is a lie. This is how it actually is. So everything was weird. But yeah, so the current state of the project is that we implemented the 4 RPC endpoints, and we implemented that for like forks after alter, which is all the forks that support light clients. We implemented 2 databases, one for light client updates and one for light client bootstraps, to store them and not have to manually compute them each time. And yeah, and also we implemented saving updates and bootstrap when receiving new blocks. Unfortunately, not still we haven't still implemented saving them while syncing. And also the P2P events and topics were implemented, so these functions are not only exposed through the Beacon RPC, they are exposed through the P2P network as well. And these are all visible on the EP of Light Client branch on Prism. Oh yeah, we have a well, kind of demo. So these are old, but this is the Nimbus server, and this is our server. If we reload them at the same time, if we are lucky, we get the same result. Yeah, kind of the same result. And so the difference, as you can see, is that we have this bug which gives us 3 more execution branches, and we have to debug and see why. Yeah, but mainly we can see that this is just one of the RPC endpoints, but this is for the demo. They're mainly working correctly.
Yeah, as of the next steps, we do have some work left, and the first of all would be we would need to test it out on a testnet, and of course, like, measure the test performance and optimize it according to that. As also Bastian said before, like, we still don't save updates or bootstraps while syncing, which would be nice to have. So we do plan to add that too. And after that, yeah, adding like client stuff to E2A tests and kurtosis, yeah, that's for mainly for all testing for all the forks. So that's for the next steps. And yeah, almost all consensus layers support light clients now, including Nimbus, Lodestar. So yeah, Prism is also into the game now. And special thanks to Radek and Josh and Mario for the cohort, and Radek for the awesome mentoring here. Thank you.
Thank you very much.
Thank you very much, guys. Yeah, I really appreciate you sharing all of this. Do we have any question for Bastian, Rupam? Yeah, there.
Excuse me, I have to scream. Do you know if there's any plans to add endpoints to generate proofs?
Sorry, add what?
To add proofs. So, like, the Lightline data set is very limited.
Yeah.
There's proofs to, like, prove the execution branch and the finalized header. But say you wanted to prove something else in the beacon state, like block roots. What would be super useful if there was an endpoint to say, I want to prove block roots at this index, and just return the hash. I feel like that's super missing from the Lightline spec.
Yeah. So there are multiple EIPs open right now that work on adding, getting proofs from the execution clients, not the consensus clients. But yeah, there are multiple open PRs, I think at least 4, that point to different parts of the block where you can get different proofs and then validate them using all these roots that are in the block header.
Okay, so but no beacon state proofs yet.
Beacon state proofs? We have the state root hash in the block header. So if you have the proofs and if you have the data, you can check that against this state root.
Yeah, but so what I mean is, like, say you want to prove anything in the beacon state. At the moment, you need to download the whole beacon state SSE, right? And then you have to, like, create the tree and then generate the proof hashes yourself. But, like, for instance, Lodestar has an endpoint where you can say, I want to prove this piece of the beacon state, and then they just return the proof. That would be really cool if all the clients can add it, because I think sometimes the apps using the Lightline data can't get to all the data that you'd actually need. For instance, so I work on a bridge project, and we need to prove, if you have a finalized header, that another header is an ancestor of that block. And you need the block roots proofs to do that, but it's missing from the Lightline data.
Yeah, that is true. I don't think that's, and there is such a thing in Prism right now. But Maybe.
Hi, I'm from Prism. So yeah, recently actually we had another person asking us the same question. So we are actively looking into that. So even if it is not in a official light client, like a future plans for unofficial specification, it's definitely another point I would like to add. So we can talk to Nimbus how they do that, and yeah, I think in the next few months I hope we will have something to share with everyone.
Awesome, that's great news. Thanks.
Thank you so much, Radek. Yeah.
Yeah, I just wanted to say thank you for this project. I had lost all hope of Prism ever supporting the light client, so thank you.
Yeah, awesome. Yeah.
Okay, quite quick question. Maybe my understanding in proofs and stuff quite limited, but can you, for example, bootstrap your light node from consensus client and then start to query the RPC provider for the latest data? So you would unload basically all the RPC calls from consensus clients.
So so you could use, if I'm understanding your question correctly, you're asking if you can, instead of asking the RPC providers for data, ask consensus node for data? No? Okay.
The other way around, yeah. As I understood, you get the latest block data, like
block header, latest block headers from the
client.
consensus node, yes.
But can you do this from RPC clients?
Well, yes, I think so. You can do that, but like the point is that you basically check and verify all these updates one by one using the sync committee signature. So it doesn't really matter where you get those updates from, as long as you have everyone in order, from where you start. And if this is all dependent on if your first trusted block route is actually part of the chain. So if you've been tricked to use something that's not on the chain and is on a fake chain, then you will keep up on that and you won't know what's wrong. But yeah, you can definitely get the updates from anywhere and just verify them one by one.
Okay, awesome. Thank you so much, guys. Maybe one more question or comment or anything? Otherwise, yeah, huge thanks again. Thank you so much for all your work, all your contributions, yeah, and the presentation. Thanks.
Thank you very much.
Awesome. And next up is Rose. So let's set up another PC. Hopefully it will work. Yeah. Okay, Mr. Singer starting in a minute for another presentation. So this time it's Rose speaking about her work on C# implementation of peer-to-peer. This is a new library for the peer-to-peer implementation. As you know, there is a big problem happening recently because Protocol Labs stopped funding the lib peer-to-peer implementations, which means that now we kind of need to manage it more independently. So there is one in work in C#. There is another project in fellowship, which is implementation in Go for Prism. And we will actually attach it to this session, but we are starting with Rose here about C#. So please go ahead.
Hi guys, so my project is about as visible in the screen, C#. So before diving deep into my
Do you have a signal? No signal? Do you have a signal from this? Or can you, is it the same slides that you, yeah, so can you maybe put the slides from the, so instead of your computer they are going to use those, because they have those slides there.
Yeah, so before diving deep into my contributions, I would first Before diving deep into my contribution, I would first like to go through the introduction of the libp2p. So, libp2p is a modular networking framework library used by the peers to communicate in a distributed network. It comprises of various protocols like the transport protocol, stream multiplexers, entity transversal, etc. And when compared with the Dev-P2P, it's more modular and interoperable. Dev-P2P is more concerned to the Ethereum's needs specifically. So it comprises of various components. So the first component is transport. So like when a peer is connected to the internet, it basically shares and sends the bytes and bits to the via IP and TCP connection, which is like the combination of the internet protocol, which is responsible for the addressing and the sending data packets. And for the TCP, Transport Control Protocol, it's responsible for the sequencing of the data, like the order of the data packets that have been moved to the sender. It's been the same order as of the receiver. Moving on to the next, the handshake. So basically, when we have a TCP or IP connection, it's not secure. We need to secure the connection to transmit the data. So, so the handshake is for the secure communication channel for the message exchanges. So it comprises of the TLS protocol and the noise protocol. Also, like the QIC is like one kind of transport which has the inbuilt encryption towards it. Yeah. So moving on to the next. The protocol negotiation. So during the selection of the multi-stream, there are various multi-streams that the client can support, right? So we need to negotiate over one particular stream. So that's what the protocol negotiation is there, like that was the negotiation of the protocol happens between the peers when they are, trying to have a connection between them. Multiplexing. So multiplexing is used for creating multiple virtual connections within a stream. So it's like a more scalable connection when the peer wants to send the multiple stream of messages over a network. So it comprises the MPlex and the YAMX. It's fast and efficient. Now I would like to move on to my contribution towards it. So like I built the full implementation of the TLS protocol. So I would like to give the introduction of the TLS protocol. So like TLS protocol is a secure layer communication used to encrypt data and authenticate peers. So how it works? So basically, during the handshake, peers so peers are not compiled to use their original public host key. They can use any arbitrary key types, and so. Like then peers use their host key along with into the libp2p public key extension. So libp2p public key extension comprises of two parts, that is the signature and the host key. So for making the signature, the endpoints, what they do is they add on the string libp2p TLS handshake along with the now moving on to the perf protocol. So perf protocol is basically used to measure how fast the libp2p works. It's a benchmarking protocol, and it depends upon the two scenarios, like the throughput per second and also the handshakes per second. So yeah, so like it comprises of the two tests, update test and the download speed test. So what happens with the update speed test is that the client configures the server to respond with the 0 bytes. That means the client will send the data and the server doesn't need to send back the data. So once the predetermined bytes has been sent to the server, the client closes the connection. So it means, so it closes the connections and the time is calculated for the same, and that's how the upload speed test has been calculated. Moving on to the download speed test. So download speed test, the client configures server to send over the n bytes, which is like the total bytes that will be downloaded from the server. So then like the server sends the data, and it yeah, and that's the time is calculated, and that's how the download speed test is conducted. So here's the screenshot showing the time seconds for the download speed test. It's like I haven't fully implemented it. It's in progress, and like here's the link for the PR, and like the mentor has suggested some changes, so like I need to work. It's in progress. Moving on to the next. So the next thing that I implemented was the noise protocol feature addition. So so as described earlier, that that during the protocol negotiation, we need to select the particular protocol for like the stream multiplexing, right? So so what happens is like we can fasten the process during the handshake itself. Like we can combine the handshake and the protocol negotiation as well. So it can be done with the help of the noise extensions. It's a particular feature of the noise. So like what happens is like so like there is the list of the protocols that the client supports, and there's a list of protocols that the server supports. And then when they're doing the handshake, so the for loop will be conducted through it, and like the first common protocol will be selected. And yeah, so here's the merged PR for the same. And thank you.
Thank you so much, Rose. Before we continue with the second half of this presentation, do we have questions on this part, on Rose? Anyone? Comments, questions? Okay, we can slowly move on then, guys. Come to please plug in. Yeah, because the story of this project is that it was started as a joint effort, but then it's split into these parts. So we have the C# part by Rose, and we continue with the Prism implementation with Kira and Richa. So yeah, I promised you you will see Richa on the stage again today, and here it is. So yeah, yeah, we need to switch to HDMI. There was a question for Rose. Can you estimate the time required to develop in a new language?
Could you more elaborate the question, like what's like the is it like the compilation time, or like to develop a new language, or what? Yeah, so I've been working for the past 3 months for this. Yeah, so I've been contributing to it from the past 3 months.
Yeah, thank you. And if we can switch to HDMI, we have the slides ready. Very well. Yeah. Is it yours? Just click on the slideshow. No, because is it from the computer? Ah, yeah, okay. I see what's happening. It's mirrored. Yeah, yeah. Please use the keys to change. Okay. You need to you need to use the keyboard. Okay, go ahead, guys. Yeah.
All right. Yeah, the project was initially started as a collaborated effort on like 3 fellows. Maxim, who did like most of the implementation part, is not here today, and then Richa and me. So yeah, our part of the project was since like libp2p is like used by pretty much every consensus clients. So we basically were trying to eliminate the use of integral parts for Prism. Yeah, since I think they announced like few months ago that they were going to stop the maintenance of libp2p. So yeah, this project was basically trying to help Prism team to enable this. Yeah, it also enables elimination of the redundant components from the Go libp2p, which are not really used, and like it just covers a lot of spaghetti code in the Prism code base, and still not sacrifice on any kind of performance. And of course, like implementing this project would involve a deep understanding of libp2p library.
Yeah, moving forward with the project structure. So what we did, we divided the project into several segments, since our main motivation was to remove the redundant parts of the libp2p, to have the components of libp2p which were basically used by the Prism team. So we started with understanding how libp2p was actually working and how Prism was leveraging the libp2p protocol. So we segregated the components, like what all libp2p had and what all we actually needed for the Prism. Then yeah, we filtered the elements, and there were several elements which could have been reused, as they were separate standalone components, and several components which were to be implemented or refactored. So we filtered out those, and then the next step was to implement the components in the package form in the Prism code base itself, and then testing. Next, we had to integrate it with the Prism code base to switch from the libp2p protocol implementation to the in-house implementation. And next was to do the performance analysis and optimize the code for better performance, or at least the same performance as was with the libp2p protocol. So how we move ahead. So first we worked on segregating the components. So as we can, we found out the main components which were actually used by Prism in libp2p. So there were some components for config, for basic configuration of the Prism basic configuration of libp2p for Prism, including the peer or the address configurations or the key configurations for cryptographic connections. Then the second one was main, which was basically linked with the config for actually making the connections or the starting configurations. Then there were TCP transport. So there were two transports which were, there are multiple transports protocols which were available in libp2p, but the Prism mainly uses the TCP and not the quick protocol. So we eliminated the quick transport and implemented the TCP one. Then there were TLS, which was used by quick transport again, and the TCP. So yeah, next coming to the multiplexers, there were MPlex and YAMX implemented within libp2p, but the Prism only used the YAMX. So we eliminated the MPlex there, and then there were noise, which were just to be used as it is from the libp2p. Then there were several more components: upgrader, peer store, the network, and the host. Apart from this, the connection gator and the connection manager, they were not to be used, or yeah, they were small segments which we just included it in the main or the config. And then talking about the gossip sub, these were the things which could be reused or eliminated. Next. Yeah, so how we implemented, so yeah, we have the components ready for the config, main, and the TCP transport, then the YAMX, upgrader, and other peer store, network swarm, and the host. So gossip sub and the remaining components were either they were not to be used or they were to be integrated in the final protocol as it is from the libp2p. So yeah, these are the main components that were to be implemented as we figured out in our first step. next, we can move on how we are going to move ahead. So we have the individual components ready. The next step would be to integrate the individual components, make the smaller code changes which are needed to actually test and connect the different individual components. The next would be testing and benchmarking and a complete protocol within the Prism. And then finally, optimizing for better performances. Yeah, thank you.
Thank you very much, both of you. And we have questions for Kira, Richa, about the Prism peer-to-peer Go library. Anyone? Okay, any comments, questions, last chance? There is, sorry. Yeah, it is the same one from before, okay, yeah. Anyway, please submit online questions if you are on the stream over there. Otherwise, we'll slowly move. Kira, you continue, right? And we have Caleb as well, yeah. Just get ready, guys. And yeah, before we switch, you can still ask questions. Okay. Yeah, okay. The next session we have the online slides, right? Yeah. It's the next session. Yeah. So. The next session, again, we have Kieran stays on the stage and Caleb. They've been working on the ePBS implementation, the Enshrined Proposer Builder Separation, and other important projects in Ethereum right now. In Ethereum, we embraced the Proposer Builder Separation, but it's time to enshrine it in the protocol, make protocol aware of what's happening with actual proposers and builders. And Caleb and Kira has been working on implementing it in Nimbus and Prism client. So you might see that the consensus clients are doing a great progress on guys, you don't have online slides? It's in the thing, right? Because you're not plugged in here. Yeah, okay. Yeah, just waiting for slides again. And this is going to be our last session of this morning part of the EPF day. So I guess we can wait for it a minute. Yeah, again, Caleb and Kira on Prism and Nimbus ePBS implementation. The CL clients are doing the work, pushing for the ePBS, and our fellows were there to help. So yeah. That's the wrong one. The ePBS, it says there in the one before. Ah, that's the one. Perfect. Thank you so much. So yeah, the stage is yours. Go ahead.
Hi, good afternoon, everyone. So my name is Caleb. I've been working on ePBS implementation in the Nimbus consensus clients. So coming into EPF, the motivation for me initially was choosing a project that touched on almost every major part of the consensus client because I wanted to have a deeper understanding of the protocol in itself. So I decided to choose EIP 7732, Enshrined Proposer Builder Separation. It was proposed to be implemented in Nimbus, Prism initially, but there was need for client diversity and to have it implemented in multiple clients. So basically, what the EIP does is basically separating the Ethereum block into a consensus and execution, into the consensus and execution parts, basically. So, and it has a mechanism for the proposer to be able to choose a builder on-chain or on-protocol, which is currently done off-protocol. So it fundamentally changes the way a block is validated by decoupling the execution validation from the consensus validation. So currently, Beacon block proposers, they request a hash tree root from a third-party builder via a relay. They submit a signed blinded Beacon block to that trusted relay. The relay is responsible for replacing that hash tree root with the full execution payload submitted by the builder, basically. The relay is responsible for like selecting the best bid from the builder and carrying out the transaction, basically. So this project was about solving this trust issue, basically, because so we are trying to like enshrine this. Currently, PBS exists, but outside of the protocol. So it's just basically trying to enshrine it in the protocol, exactly. So it helps to guarantee two major things, right? A proposal payment safety, and a builder payload safety. So it just goes to say, if an honest builder submits, submits a payload and like commits to a particular beacon block, it should always get paid, or he or she should always get paid. And the builder payload safety just basically means if he publishes a payload, then that block should become canonical. So core changes, and basically our approach was basically just, it's a research work that has been in the pipeline for a long while. So what we just did was basically, was like implementing it based on the spec that had already been written, right? So the major changes were like, in the execution layer, there was no changes required. So basically it keeps the execution people happy. Then we just had to like make sure almost all the implementation had to be done on the consensus layer, which was like the two major parts was the beacon chain and the fork choice logic. The fork choice logic is, I don't know, it's quite complex really, but quite complex because currently that's the point we are at, and there's a new so that's what we are implementing next, basically.
All right, I'm gonna expand on that a bit. Basically fork choice, when we started the project, we had basically two designs. One is like block auction and slot auction. By the end of the project, whatever was built was basically replaced by a new design, thanks to Francesco. But yeah, I'm gonna explain like what we did during the cohort and like what was the design that we are working on. Yeah, so basically this what ePBS does is separate the consensus and execution validation of the block, which means that right now the Ethereum block has only like 2 seconds to do like everything, like validate DA or produce the KCG proofs. What this will do is like separate the consensus block from the execution block. So for the first 3 seconds, like proposers or validators can validate the consensus block, and the execution validation can be deferred to like the next 3 seconds of like next slot of the first 3 seconds of the next slot. So basically you will get like 12 to 15 seconds to validate DA instead of 1 or 2, and then also there will be like more time to produce KCG proofs. Since like consensus block no longer carries execution, this also results in faster propagation, like faster network propagation and verification of that. And yeah, this also ensures that consensus liveness no longer depends on the execution results or the finality of the execution block. One last point here is like any builder can set the floor for the auction through P2P market space. This like remains unchanged. Like this is what happens right now, except this is done like on a off-protocol relay network. Yeah, so basically this is what an ePBS slot looks like. Yeah, so it is divided in basically 4 intervals. The first three seconds is when honest validators would gather signed bits or like the signed execution payload header from builders, and then submit their consensus block, or we call it signed beacon block with these bits. For the second part, it remains unchanged as it is right now. Honest validators would submit their attestations, what is like happening right now as well. For the third interval, the aggregators would aggregate these attestations and the builder broadcasts either the full payload or a message indicating that whether they are withholding the payload or yeah, I think basically that's it. For the fourth interval, some validators are selected to form a new payload timeliness committee. And which kind of attest to the presence and timeliness of the builder's payload. Okay. Yeah. So this is like what. Okay. Yeah. So at any given slot, the blockchain's head can be like a block. Can be like a block from a previous slot if the current slot's proposer did not submit a block. So in this case, all the validators would attach to the parent block, and then like the slot would go like without a block. In the second case, it would be an empty block if proposer does not submit any block in the current slot, but the builder if the proposer submits a block in the current slot and the builder did not reveal any payload on time. And in the third case, it would be like a full block when both proposer and builder would reveal the block on time. Yeah, so this was the initial fork choice rule that we are like basing our implementation on. This is called block auction design, which contained like new payload and withheld boost. So basically, this is what our mentors like tested like just 2 days before the Devcon. I think, yeah, it's on 7th. Yeah. So this assumes that the block here, the block propagated here assumes that it is tested on local interop, and meaning like that a proposer and builder are the same entities. We haven't like yet tested, I think, on the P2P side of things yet. But yeah, for the future work, implement the new fork choice design. If you have time, I can like expand on that a bit more. But yeah, and then like hope that more clients join our more clients join and like start the implementation for ePBS. I think Teku has already started it, and Caleb and I am like working on Nimbus, and I think Portus and Terrence have been like working relentlessly on the Prism side of things. And then like update the fork choose consensus spec according to the new design, do the spec test, and like at last do the DevNet testing. I don't know if do we have time. Yeah, I think. Yeah, this is the new, like this is what a slot would look like in a new fork choice design. This was proposed by Francesco in the last ePBS breakout room. This basically combines ePBS, Fossil, and DS into a unified fork choice framework. And like it will support all three of this, or like all in one fork choice, which will work for all of them. So it basically uses availability committee. So the payload timeliness committee is like renamed to the availability committee here, and like now it doesn't only just votes on the timeliness of the block, but also votes on the payload and the block availability. While also enforcing the inclusion list through deadlines. So if you see, I think it's at the 10th second. So there's like a deadline for freezing of including the ILs. That's what basically IL committee kind of ensures. Not to go more deep on the fossil side of things, but if we include fossil, it also touches the execution side of things. And finally, a special thanks to all the mentors, Portus, Terrence, and Tersek, and the excellent EF researchers who came up with a new simple design, Barnaby and Francesco, and Mario and Josh for organizing this EPF. Thank you.
Thank you very much, guys. Thank you for Yeah, thank you so much, guys. Thank you for the kind words. So before we wrap it up, do we have any questions, comments for Caleb and Kira? There's a ton of stuff, a lot of work done on both implementations. I think it's incredible, guys. And if you have any thoughts about it, any comments, any questions, feel free to raise your hand. And yeah, okay. Otherwise, I guess we'll wrap it up here. Yeah. If there is anything, I mean, we will be hanging around. Like, feel free to reach us out. Thank you so much, guys. And yeah, with this presentation, yeah, let's give it up again once again for Kira and Caleb. Thank you so much, guys. Incredible work. And yeah, right now we are finishing the morning block of presentations for EPF Day. As you can see, it's very intense. We have a ton of presentations. We have a ton of people who did a lot of work in the past 5 months. So it's very dense, very intense. And we need to take a break. So we will be back at 2 p.m. in 45 minutes, roughly. So we have a lunch break now, and we will see you back at 2 p.m. with more presentations and then discussion panel with some former fellows. So please come hang out, come join us later as well. Thank you, everyone. See you soon.
Oh, sorry. I have sleep. Oh, yeah, yes. Okay. Okay. Hello, everyone. My name is Jin Mingjian. My project for EPF Cohort 5 is Grandine on Windows. So in the hood, I will discuss the cross-platform engineering challenge for Prism client challenges. All of my challenges can sum up to one sentence. It is hard to run Prism validator on native Windows. This is my challenges table. We have a memory allocator problem. We have a stack overflow. We have a test failure. We have a REST running program. All this is just special for Windows. We have a missing system metrics. And we also have unsafe Windows API programs. We also have special use case for Windows, like screen server or sleeping. Finally, I was found it was not easy to run a validator. Yeah. Okay, let's see how we can solve these challenges. First, for JMemlock, the workaround is solution. We just disable it, like most Rust project. We in favor the Windows built-in allocator. The truth is, JMemlock is great for server side, but neither necessary for edge, nor better. Okay, for the Stack Overflow in debug mode, in fact, this is a big challenge because for developers, because it's proven to you from debugging. The workaround is your solution. You just run the project in release mode. The direct reason for this Stack Overflow is because there are a big on-stack allocation in debug mode in Rust library P2P core stack. This is detail of core chain, but if I have enough time, we'll come back. So for this challenge, I have two reflections. One is we should limit the globe status, and I recommend to use a top singleton to manage other singleton. This is a common pattern in Rust project, yes. Secondly, you say, in fact, we have a the true program lives in the deep library, so you cannot easily fix it. So we just use a workaround. In the debugging of this Stack Overflow, I have reviewed the lib P2P source code and the related source code. I found there are many engineering problems. So I suggest we should rethink and even we may overhaul our list fundament libraries like library P2P because it's really crucial for our whole Ethereum core infrastructure. Okay. For the test failures, in the consensus spec test, it's just because the default configuration of a gate on Windows, it is inconsistent. The configuration. This will cause the gate on Windows changes the SSZ related test architecture. So we have this silly test failure. But the lesson here is the consistency and the debuggability are so important for developers permanent. So we'll never overemphasize on this topic, I think. Okay, we come to the REST running program. In fact, it's also a big problem because we need two kinds of client instance running in your computer, in your node, to form a full validator. Yes, so you cannot just run a consensus client, right? The rest, you can, in fact, we made a program is a database commit error 998. In fact, now mailing list on our course, but in fact it still exists. The workaround is just we run the rest in WSL on Windows. The great news, the WSL Windows can interact with the native Windows seamlessly, but the big problem here is we are going to another inconsistent case. For the same database file, it can work, the RAID can work where on Linux, but cannot work on Windows. Okay, the lessons here, there are two lessons here. The first is even for REST. By REST, it is a well-engineered Rust project, but it is still not good and ready for running on Windows. Okay, then the other point lesson here we want to, it's a big program. We want to mention which is related to the root of the problem is the backend database engine of REST. It is MDBX key value embedding database, but if we have enough time, we will come back here. For the missing system metrics, the work solution is I just implement what the missing. So there are two interesting points here I want to point. The first is the system-related matrix. In fact, has its API proposed from the Beacon Chain team. So I feel with our Ethereum has a great community here. Yes. The second point here is after my fix, the Grandine now has a better system-related matrix support on Windows than Lighthouse. You know, the Grandine is a minor client, but the Lighthouse is a major client. Okay. For the unsafe Windows API, we just upstreamed unsafes to the upstream libraries, but the library pitfall for most Rust project is the forbidden in Lynch, which most of Rust team like to use it, but in fact just work the codes in the current workspace, not for rows in the libraries. So, okay, for the special use case for Windows, like that's no problem, like the screen server and the sleeping, that's okay, we can recover from it. Finally, we come to the last challenge I have is what I said, it is not easy to run Ethereum validators. The solution for me is just to learn and to try. Okay, but I think this may be okay for me, like a great development, but this is not good for common users, I think. So I propose in the future we can have we can explore great integration of our current laid client in our Ethereum core infrastructure. Okay. Finally, I hope running a Ethereum validator should be less hard. Okay. We come to the thought and the conclusions. Firstly, Rust is great for cross-platform. Yes, we have many different targets we support, but for current situation, we have not fully utilized it yet. Secondly, Prism clients often share common implement and fundamental libraries, as we say, the library P2P like. But if one have a bug in the fundamental libraries, in fact, from engineering, it's not good. It will affect upon the infrastructure, world infrastructure client. So this, I think, it is defective for the client diversity. Yes. Third, I think we can get more best practice from wider Rust ecosystem. Finally, I think ePF is great because I'm this Cohort 5, ePF Cohort 5. So in this process, ePF, I began to have a deep understanding of the protocol, the development, and the source code of several core clients. Yes. Finally, as I want to say big thanks to my mentor, the Soliers from Grandine team and Weekday from Grandine. Sorry, I'm not exactly the Weekday's name, so this is a GitHub handler. I'm also appreciate Team Verkle. He introduced the ePF to me, and also appreciate Joshua and Majoro from ePF. Thanks for your great help. Thanks for all of your. Okay, this is about me. So I'm great in Rust database and JK and Prism core infrastructure. So if you guys has this related opportunity, you can don't hesitate to contact me. Thank you. That's my present.
All right, thanks a lot, Jin. Any questions for Jin on his project on Grandine support for Windows? All right, next we will welcome up Boma and Zarathustra for their project. Are you guys going to plug in? I hope so. Do you need All right, let's hear it for Zarathustra and Boma.
Hi, guys. So we worked on consensus client performance profiling. Both of us had the similar interest, starting off with Grandine and branching out a bit, as you do during work on a project. There's a couple of repos listed there. Two of them are on GitHub, because that's where everybody else is. And I myself prefer GitLab, so I threw that in. I'm going to hand it to Boma, who's going to take the first bit.
Okay. Hello. Okay, sorry. My name is Messi, and I'm here to make a project presentation. Although our project shifted a little bit, the initial goal was to work on security and testing, but due to some, I underestimated some things, and so I had to focus on performance analysis, a comparative analysis between the consensus client. Okay. So, Okay. Sorry. So the initial goal was to do a security and reliability of grinding, and then there was a shift in focus, which transitioned to profiling multiple clients due to technical challenges which I faced. Oh, okay. Sorry. So first of all, I used so many performance security tools. The ones that stood out to me was a flame graph and then implementing a timing matrix on grinding. This is an example of what a flame graph looks like. Although it's not quite readable because you have to like click in and then out to really view. But okay. So looking at these stacks, grinding is actually performing very well from the stack overview, although there is a drop down from the Tokyo runtime, which is at 61.79%, which had a minus 35% drop down. So the key observation here is there is a high trend utilization on 97% in system trends and initial setup, significant drop down to 62 in Tokyo runtime operations, and then a consistent performance across Tokyo task management. Also, multi-threaded worker execution showing similar patterns in different narratives. Is that okay? Okay, sorry. So this is the 35%. Looking at the system trade level, which is 97%, then the Tokyo runtime, which is 62%, and then which identifies the 35% drop down. So the cliff there is kind of huge. And the high performance areas are trade initialization, system level operations, and then code trend management, which Grandine pretty handled very well and then performed very well in that aspect. So areas of investigation, okay, a disclaimer, this is a research project. It's still, I will call it a research because so many things can change and then I might be wrong in some cases. So the areas of investigation for me is the Tokyo ties scheduling, which is at 62%, and then the sync runtime overhead and the tax profiling efficiency. And talking about the timing metrics, which I had to implement, for now, Silas suggested that I had to do a comparative analysis between grinding and then Lighthouse. So for now, I only have the data on grinding, and I'm yet to produce the data for Lighthouse to properly do a comparative analysis. But this is basically how the data looks like, and I'm hoping to use this to do more investigation on to do more analysis on formal verification and fuzzing, creating a targeted fuzzing and what's it called? Primitive analysis. Sorry. And hold on. So the reason why I had to use tools like the frame graph and the timing metrics was to help me understand more about the consensus client, because I really underestimated what it is to force and build a fuzzer for a consensus client. Because coming from a smart contract security background, I thought it was the same perspective, but I was proven wrong, and the complexity was overwhelming. But using this analysis and using this data, I think I'll be able to produce and to come up with a strategy in order to have to build a fuzzer, which has to do with making it a targeted fuzzer and also for formal verification. Because I understood that there is not much work on formal verification on Ethereum consensus clients. Thank you. I can hand it over to you.
So, small premise to the second part. So, as I mentioned, we initially started working on Grandine. There was a slight shift in focus, transitioned to doing this profiling of multiple clients. At least that was what I focused on. DevOps emphasis. I decided to go there since I have no experience doing any sort of DevOps work, and I figured having a couple of months seemed like a lot of time here. That's a good thing to pick up. So that was fun. Build my own server from second-hand part. First time doing that, running Proxmox. Pretty interesting experience, learned a lot. Challenges, hardware constraints. I thought I had sufficient amount, but turned out that maybe the minimal required specs listed are not entirely enough to run all the nodes on a single server. at least not the one that I decided to assemble. And regarding the outcome, yeah, well, there's limited data. The results are modest, but valuable insight into running Ethereum nodes was acquired. So let me tell you a bit about the setup that I used. So I listed on the left side for you guys the consensus clients that are there and the versions of those that I used. 2 of them don't have a version specified, and that's because I didn't manage to run them, so they were not included. I would like to include them at a later stage when I have the capacity to do so. In terms of hardware, I have dedicated 8 cores to each of these. RAM 32 gigabytes, and the disk space is 2 terabytes, NVMe drive, which is sufficient for all these clients to not be limited there. In the setup, I make sure that each of them running on a virtual machine is limited to this, basically. So there's no way that if one of the VMs isn't using all of its RAM, that one of the others could use it because it's available. This is normally something that Proxmox supports, but that, of course, doesn't allow for a proper comparative analysis. Then the services that I also got to work with and got to learn about, and Nethermind, of course I needed an execution client, and a whole bunch of other services that anybody who's done anything in DevOps probably knows. So Prometheus, obviously, for metrics. I'm not going to mention them all, but I will just say that these were a lot of tools that were new to me. Quite interesting to see how many services you actually need to run such a node in a useful way, so that you actually can monitor what's going on. Then I'm going to show a couple of figures on some of the data. It's a bit older data, but so be it. So this is the CPU usage that I measured over the course of about a week, a little longer, for 4 of the consensus clients that I mentioned. And now the question obviously is, what does this mean? And I don't have a crystal clear answer to you. I do notice some things, which you'll probably also notice straight away, which is that Grandine seems, on the average, to have the lowest CPU usage. But there's somewhere a spike in the middle. I see that in a later figure, in the next figure I'll show as well. And honestly, I'm curious what happened there, but I simply don't know. I probably need more data. From the metrics alone, it's not so clear. It could be various things. It might be something network related, could be something client specific. Simply don't have an answer for you there. Here I looked at the memory usage of the different clients. Also, you see the same spike in the same period, but it's for a different client. So yeah, there's definitely something going on there, and I would say that my suspicion is that it has something to do with my server at that point, since I see this weird pattern. But like I said, I have no straight answers for you. And then the last figure I will show. I think this is actually one of the things that is highly relevant. I only show Grandine and Lighthouse here because the initial focus was more or less on Grandine, and well, for comparison, also taking into consideration Lighthouse. So the number of pairs that you have is obviously very important. And you can see that there are actually quite large spikes to the downside. I have the limit set at 100, so that's why it looks kind of artificially kept there. But yeah, if you lose a lot of pairs, that's obviously not a good sign. And well, it seems to be fairly, maybe not stable enough, or not as stable as you might want it. So in terms of outlook, what I would like to do is refine and scale this node management. So I now have almost automated setup for the provisioning of my VMs. I would still need to switch to NixOS or Talos to have it fairly immutable and idempotent. Then I want to integrate ETH Docker. This is something that I simply didn't have enough time to properly look into. So far what I've been using is Sedge. Well, I started with simple scripts and running local binaries, and eventually went on to use Docker Compose. But yeah, I would like to move to Kubernetes, and I would like to also explore ETH Docker, because I think it offers some of the things that I was lacking or missing in Sedge. And then I only very recently, that is to say yesterday, learned about the secret shared validator. So I'm going to look into this. This is something in the direction that I was thinking. I want to use this setup. I want to use this setup myself with an agentic system, because there I have a background. So I think it might actually partly at least overlap with the secret shared validator setup, because I was thinking in that same direction. And lastly, I want to optimize the data queries, because the idea of this agentic system would be to integrate those metrics so that the agent can proactively take the necessary measures. For example, manage your node. If you see that your peers are getting too low, maybe you need to, well, do something to fix that. Yeah, that is all I have for you. So then I only have a thank you slide left. Obviously, Mario and Josh, it was amazing. Thanks so much for well, all the time and effort that you guys spent and granting us this opportunity to be part of the EPF. Yeah, I think that's it. So if there are any questions, then please. Yeah.
Hey, thank you for an amazing talk. I was wondering if the nodes that you ran were validators or just nodes?
No, also validators.
Also validators. Yeah. Okay, so it might be nice to see the difference between, for each client, what's different if they're a validator and if they're not.
Yeah, I agree. There's lots of experiments you could do. Yeah. Really lots more. I would have liked to have done more of them. But it's, as Boma already said, it's quite overwhelming because even when I thought I had all the pieces and sort of working, and then you need to learn PromQL, okay, and then you learn a bit of PromQL, and then you see all the metrics that are there. For example, Grafana, which I also used a little bit at some point, I just decided, okay, I just cannot do it. So, yeah, I agree. There's lots more. And those things would be interesting to look at, yeah.
Yeah, amazing. Thank you.
Any other questions? Mario?
Yeah, I was wondering because you mentioned the setup with Proxmox and then you want to automatize it, set up with Nix. It's really cool. You didn't really have any slides, like some more specs about it. Like, for example, what virtualization are you using with Proxmox? Like KVM or LXC or, yeah?
KVM is what I'm using, but I could explore maybe alternatives. I haven't explored any alternatives there. So, you think it's worth exploring?
Just the Linux containers are good for servers as well. And I was wondering, like, because Proxmox supports both, and you just, you didn't have the details there, so I was wondering, like, which one.
No, this is true. No, this I use it's the lightweight version, right? So for Linux, that's the preferred option, I would say.
Yeah, cool. Thanks so much. Yeah.
All right. Thank you, guys. Next up, we have another presentation from Hong Liang, and his presentation will be on his work on the PeerDAS in Grandine as well. Let's welcome Hong Liang.
Thank you, Joe, for the introduction. So my project is working on improving PeerDAS in Grandine, and oh. Okay, thank you. Okay, so the motivation behind the project, because there are some interesting topic and change that are proposed by the client team, like why I pick up PeerDAS to be working on, and why I choose Grandine to contribute to. So because like at the time that I start the program, PeerDAS was considered to be included in the Pectra, so they had like a specific deadline, and also there is a active research and development, and also like a running DevNet that all our client team like working on and to implement the PeerDAS. So yeah, but due to the the DevNet instability and the interoperability issue that happening in the previous DevNet, that's why it moved into the full saga, the network upgrade after the Petra one. And also the Grandine is written in Rust because I'm also familiar with the programming language, and then you might ask, like, Lighthouse also written in Rust as well, but why I didn't contribute to Lighthouse anyway. But because of the last point, because Grandine is like a new client, consensus client, and the team is like a small, on like only 4 people specifically, so they don't have like capacity to handle different things. Yes, so that's why I would like to contribute to them. Yeah. So a little bit of context about the PeerDAS. So PeerDAS is like the networking chain to the protocol, Ethereum protocol, which allow the database sampling and peer to do the database sampling without like to download all of the blob that in the network to ensure the blob availability. Just like download just a few chunks of it. So now, like without PeerDAS, so each node have to download and to participate in the gossip shop, the subnet. So all the block like in the block that have like 6 blobs in it, so they have to download all of them. Like there's no like the database sampling in there. So then if like the PeerDAS activated, so like the node like only to participate a few chunks of it in the gossip sub, so they don't need to download the blob data, just a few chunks like in the diagram above. So the project progress. So just want to mention, like before I start working on PeerDAS, like Grandine team have done the groundwork. Already joining the first testnet of the PeerDAS, and because like the spec is evolving and changing, so like like I mentioned earlier, like the team like don't have the capacity to handle of different things, and then I joined to contribute to, and so I make work done some work on and then ready to join the PeerDAS testnet too. So there is a spec change into like switching from the PeerDAS peer sampling to the subnet sampling. So it is kind of like a simplified version of the PeerDAS. So like PeerDAS without peer sampling. So they don't like get rid of complexity of the peer sampling. Yeah, and also another spec change into the testnet too as well. So there's add the metadata v3. So it is kind of like a OPC method. Like it is just a simple like add a new field into the metadata, like the custody subnet count. So it is a small thing. And fun fact, like the testnet 2 didn't went up well. So it there's a bug in Grandine that caused like the whole testnet to be like messed up. So I'm the one that messed up. And also, at least like we found that the edge case that the spec is missing like the check in the data column sidecar with the 0 commitment. So and then later on, we relaunched the testnet 3. So there is a pull request and the change to the spec to include the validation on the 0 blob. So yeah, at least we found that the edge case on that. And then also like the testnet 3 also didn't went very well as well. So there's like a reorg from on the Prism that reorg around like 100,000 of slot. So there's still some of like uncertainty about the real root cause of the issues yet, and mainly maybe like around the peers scoring, yeah, and the rate limiting stuff. And after that, I found like, some issue regarding to the by-rank request and response, and also like some of the synchronization issue that happening previously, like Grandine like cannot synchronizing from the Genesis, yeah, and then previously they don't Grandine didn't have like the reconstruction handling. So I try to make sure like the reconstruction have been implemented before the DevNet 4, and then I implementing the rebase PeerDAS on Elytra. So it is like rebase. So the team there's a spec chain in the DevNet 4. So and another one is the engine get blobby one, but it's not done yet. So I'm working on it currently. And there are several like open PR. Okay, sorry. There are several open PR might be included as well. In one of them, the standardized metric from one of the fellow here is Gaja. He's working on it. Oh. So the next step, I will like continue and contributing to the project until like it will launch and continue implement the engine get blobby one. It is the optional one, but most of the client are already implementing this engine APIs and continue fixing bug because there are some few bugs that still in the implementation, and also continue improving the performance and clean up the code base. And yes, and there will be later on like DevNet, so I will keep up with the spec chain. So the challenge is that it is the most challenging and interesting part for me to implement the PeerDAS is mainly like to understand the concept of data ability sampling, particularly in the PeerDAS, because like it's not the important thing is not the hard part is not the implementing. Like you try to need to understand the concept, and also like to get yourself familiar with the structure of the code base on the Grandine, and also all the clients, because you need to understand the behavior, the correct behavior. Like when you debug, you will like find some of wrong behavior or something that, and then you need to check with all the client implementation, like what is their behavior, and then try to interrupt. Yeah, and my experience in the EPS, yes, it's great journey for me. Before I joined EPS, I did not understand anything about the core protocol development, and I don't know about the decision that made into the protocol chain, and it's a lot. And I must say I am a permissionless participant, and it is a great opportunity like for the public to would like to exploring the core protocol development. Is completely permissionless. Yeah. Yeah, thank you everyone.
All right, thank you. Any questions? Got one question over here.
Yeah, so a couple of questions. What did you use for your testing setup for Peers? And another one is about what was your networking stack?
For the testing, we use Cortesis for the local testing ones. So we spin up a few nodes like from a different client. So then we can test the interoperability between clients. Yeah. For the networking stack, it's the same. Like we use Cortesis, and we add some of the service to doing the monitoring and the dashboard and the metric something. Yeah.
Any other questions? Awesome. Thanks again, Ang Myung. All right, next up we have presentation from Katya, who will be talking about her work on displaying metrics for PeerDAS across a few clients.
All right. Hi, everyone. My name is Katya Ryazantseva, and my project is PeerDAS metrics specifications. Missed the slide. I'm not going to dive into what is PeerDAS. It's been mentioned already. So it's a scaling solution for data availability. And all of you know that Ethereum protocol is built with according to the consensus and execution specs. But the metrics for different clients are different. I mean, we don't have the unified metrics for the clients. It's challenging for core devs to compare the different clients. And for the DevOps team, it's challenging to monitor all the clients. There are a lot of them. And it's also difficult for research to get the unified data, to synchronize the data. So the solution is one dashboard for all clients and the unified metrics specs. So how it worked before? We had different dashboards for every client, different graphs. To compare different clients, it was quite painful. What do we have now for PeerDAS? We have a single dashboard with different clients. The metrics implemented for Grandine, for Lighthouse, for Teco, and Grandine, Lighthouse, Teco, and Prism a little bit. So for this dashboard, you can apply filters. You can choose if it's a full node or super node. You can choose one client, two clients, all clients, and you can also choose an instance and compare or monitor or wherever you need. Let's look at some examples. This blue client implemented some feature. This one is PeerDAS, and the filter is for full nodes, and it is obvious that there are some issues with it because other clients for full nodes, they have less values, and this one looks like super node. This is the case for investigating. So the next one is obviously there is some issue with one client which DevOps can catch visually or can apply the alerts, Grafana alerts as well. For researchers, this dashboard is helpful because they can build benchmarks. For example, here you can see two clients and they have the same metrics. So this means that probably the case, the benchmark with specific numbers. This dashboard is also added to kurtosis. So whenever you want to run kurtosis and you need a PeerDAS dashboard, it's already there. So no need to build your own dashboard. The dashboard is already actively used by Jimmy, by Sigma Prime. This is his notes about PeerDAS nodes, super nodes and full nodes, bandwidth, and you can see the graphs from the dashboard. Why hasn't it been done before? Because especially before the merge, there were not so many clients and it was manageable. But why do we need it now? Because the ecosystem is growing and there is more and more clients. Not so fast, but anyway, the number of clients grows. And as Perry told me, plus one client is 10 time consuming for monitoring, for testing, etc. So the benefits of metric specs. It's easier to catch errors. It's easier to save resources of teams, so you just save some time or for building, for testing, etc. It's easier to compare clients, which sometimes really important. And for researchers, it's easier to create benchmarks. Currently, PeerDAS metrics specs cover the main points of PeerDAS. They are computation, inclusion proof, KZG verification, reconstruction, gossip verification, and custody. And they also, in the discussion, gossip sub and libp2p metrics with labels for PeerDAS. This is the current state of project. Some of the metrics are already implemented. Some of them are open PRs. Some they need a review or need an adjustment. And I hope to cover all this table, but that's not the end. The roadmap, the workflow for the implementing metric is kind of like this. We discover it on, we discuss it on PeerDAS breakout rooms, then put it into the GitHub specs, and then develop, test, and if researchers need, then create the benchmarks. Then process of reviewing goes, and if it's needed, then the circle starts again, and if it's not, it's merged. But this is not the end, so PeerDAS metrics are only the beginning, I would say. The next goal is to spread it to consensus clients and later to execution layer. I would like to wrap up with the words of a poet, such an I think, client diversity for the win. This project presents Ethereum values such like client diversity and collaboration. And it wouldn't be possible without my mentors, Perry and Barnabas from ETH Pandops, and Dmitry from Teku, and Jimmy from Lighthouse. I also worked with different teams, Prism, with Grandine. I had a feedback from Megalabs. They are researchers. So yeah, I'm going to proceed with it. Thank you for your attention. If you're interested in any details, you can scan the code. And thank you.
All right, thank you, Katya. Any questions for Katya?
Thank you, Josh and Mario. That's wonderful.
I may have missed it, but how are the metrics being collected at the moment? Is it being produced by Kurtosis?
If you run it on Kurtosis, yeah, they are collected using Prometheus metrics. It's like standard stuff. Yeah. But DevOps team also has their own databases on Victoria metrics. They collect it there. So these specifications are more for internal use, for DevOps team, for researchers, but they are also available for public usage.
You mentioned CL specs. Do you know if there's any work being done on that yet?
No, but we're in discussions about building specs for libp2p and gossip sub because they are already in production, so it's difficult to kind of synchronize them. But we're trying to find the solution. How do you think would it be useful? Yeah, you find it?
We have lots of metrics, and the teams also have their lots of metrics.
this is not a must. So teams can also create their own metrics if they need like more or in different ways. So, but some of the points would be great to be synchronized in any points. Yeah.
So, is it correct that you implemented these PRs in different client teams, like into different clients? Or did
yeah,
okay.
yeah.
So do you see this moving forward to add these metrics across all the parts of the clients? Do you see this as something that you or the DevOps team would do, or is it that the clients team themselves have to implement these, like going?
The way how I see it, so we will start, we will get used to it, and when the new, for example, EIP or any other feature is delivered later, which is not yet started, the process is, for example, in research, with building the specs for the clients, we can at once, at least like we can mark the point where should be the metric. And the clients, during the building the feature or the EIP, they could bring it right into the right place. So I hope I won't do all the metrics for all the clients. So the idea is just to bring this process so it came natural and not that painful for teams.
All right, thank you.
All right, thank you, Katya.
Thank you.
All right, next up we have a presentation from Glory, who will be talking about her project over the past 5 months, integrating Ephemery testnet into Teku and Besu.
Hello, everyone. How are you guys doing today? I hope you're having a great time at Devcon. Okay, so today I'm going to be talking about native implementation of Ephemery testnet on client pairs, Teku and Besu. First of all, I'm Glory, and I would like to ask this question. How many of us have heard of the word Ephemery testnet before now? Okay, so those people that raised their hand up are people in the fellowship. So that means we still have so many persons that are yet to know about Ephemery. I remember when I started working on this project, my mentors, the guys from Teku and Besu, they were like, what is Ephemery? I've not heard of it before. So I had to start explaining. I had to share the link to the documentation for them to go through it. Okay, so with that being said, okay. All right, so why they're trying to work on it? First of all, what is Ephemery? Ephemery is a resettable short-term based testnet. So when we say it's resettable, it gets to reset itself after a given period of time. So it's not like the regular testnets that we are used to, like Sepolia or Liski and the rest of them. So Ephemery is kind of dynamic and not like the others, like I said. And so I wouldn't really want to go deep into Ephemery, so I would just be diving into what I actually worked on. So yeah, for the project, the goal of the project was for me to implement or create native support for Ephemery on Besu and Teku clients. And why was this needed? We realized that just like I asked, and most of you didn't know about Ephemery. So Ephemery is still pretty new, and we are trying to see how we can get more clients and more people to know about it and to start using it. So we want to improve the user adoption, and we want more clients to be running on Ephemery natively without having to go into the manual process of setting it up. So based on the work that I've done, initially, when I started this project, I noticed there are some work that have been done before in the past by some other fellows. And at that time, we had support for Gets, Red, and Lighthouse, and Lodestar. So work has started for these clients. I don't think they are completed yet. But as at the time I came in, I noticed there was no native support for Teku. So for that, we needed to download the Genesis SSD files and the Genesis files and all of that to do those processes manually when trying to run the node. So to avoid that headache, we decided to implement native support for it. And what does that really mean when we talk about native support? We want a situation whereby when you are trying to run a node, you can easily do something like Besu -- network Ephemery, just like you do with other supported clients like Sepolia and the rest. So, and because Ephemery is quite different, the process of implementing it on clients was not that straightforward like with other clients. So we needed to do things like trying to write some custom functions or some custom classes as well to be able to like work on the updating of the Genesis state and all that. So because we understand that Ephemery updates after a certain period of time, so there was need for a custom function to be created for that to be able to happen dynamically. So these were some of the things I did, and okay, so for the Ephemery Genesis file, I noticed the way it is structured when I checked the original repository was quite different from what Besu clients was expecting. So I had to make some changes, like added things like the /hash, the discovery nodes, and the boot node to the Genesis file itself. And also, I updated the documentation when I was done with the work, so that when you go to their documentation now, you can see, just like you see Sepolia or Liski on their doc, you can see Ephemery there and know the right command for you to run to be able to do that. And with this, we also implemented some testing, because every aspect of this project, with the way Besu client works, everything you do, you have to write tests for it. So every implementation work done here was also properly tested. And so for Teku, we did similar stuff, but with Teku, for the SEA clients, we don't use the normal JSON format file for the Genesis, so it was SSD, and it's not as easy to manipulate as you do with the Genesis format file. So with that, we needed to take a different approach and see how we can load the SSD file from the Ephemery repository to get the updated states at every given point in time. So the same thing applies with Teku. We also created a custom class and function to be able to update the Genesis states at every given point in time dynamically. So if you're running the node, you're able to get the updated state every time, so you don't need. And also with Teku, I worked on the reset feature, which means if you are running a node, you don't have to stop the node manually to go delete your database and all of those stuff. When it's due for reset, it's reset itself and then deletes all the necessary files that needs to be deleted in the DB. Yeah, so pretty much like I said earlier, so there's not much difference between the implementation on Teku and Besu, just some different files and changes that were made, which was not exactly the same thing, and then the SSD file I mentioned, and Genesis file, and all of that. Okay, so yeah, so this is like a summary of everything I did on the implementation for Teku and Besu. I completed the initial research, then created custom function for Ephemery on both Besu and the Teku clients. And then right now you can have, right now we have native support on both clients, so you can use the flag, the native flag like Besu that's network Ephemery or Teku that's network Ephemery, and you can do that as well. And then the documentations are also properly updated, and we have suitable tests for all of this. So in summary, for the whole period of the fellowship, I was able to get up to 15 PROs merged, and currently have 1 PRO that I'm still working on, and 1 open issue. So as far as work in progress goes, based on what I plan to do during the course of the fellowship, I wasn't able to get to the point where I was able to work on the reset feature. So right now I still have the reset feature to implement on Besu. And then as far as the website goes, I'm still yet to work on that, just redesigning the website and the tutorial walkthrough, which I planned to do, but I didn't have enough time to do that before now. So yeah, for the challenges, these are some of the challenges I faced. So this was my first time working on protocol development. So before now, I do normal application level development, like writing smart contracts, doing dApps and all that. So this was my first time, and it was a lot of learning process. Had to learn about the protocol, CL, EL, and that was one thing I love about this project because it gave me the opportunity to learn about those different areas. And then trying to understand the code base for each of these clients was another big problem because it wasn't even writing the code itself, but going through their code base, trying to figure out where my implementation is going to be. Those were some of the challenges I had, but thankfully enough, I had good mentors who were able to help me navigate that. So for the future of the project, I plan to continue my work on the Besu client to complete the reset feature and to also implement, there's still some little work I need to do on TechCool for the validator clients on slots processing, and then to expand the support to other clients. So right now we have some clients that don't currently have native support. So my plan is to continue working and to extend support to those other clients and also to become a validator, an Ephemery validator. So key takeaways for me, this program has given me the opportunity to dive into the Ethereum protocol itself, which was one of the reasons I joined. And then I've had the opportunity to learn a lot about what the protocol entails, client implementation, what the different clients we have in the Ethereum protocol and all of that. And then before now, I do Java. Java was actually my very first programming language when I started, but I've not done it for more than 4 years or so. But with this project, I had to come back to Java, and I was able to improve on my skills as far as Java goes, as well as testing and all that. Then for EIP, I've not actually implemented anything working with an EIP before, but this project actually gave me the opportunity to write code following an EIP, so that was really good for me. Yeah, so for my mentor, special thanks to Paul Harris from the TechCode team. Unfortunately, they are not here right now. And then thanks to Sally from the Besu team. Thanks to Mario and PK910 from the Ephemery team, and the past fellow, Ollie. When I started, I asked her some few questions, and she also shared some of her past updates with me, which was really helpful as well. And thanks to Josh and Mario once again for the opportunity and for setting this whole fellowship up. So before I go, I would like to encourage anyone here that is considering contributing to Ephemery. So if you want to do that, you can do that in different ways. You can be a node runner, you can implement on client, like I mentioned earlier, we still have some clients that need implementation. And then you can, if you're a dApp developer, you can deploy to Ephemery testnet on your dApp and run and test and see how it goes. And if you run node, you can also if you run infrastructure, you can run an infrastructure. And if you have any idea or whatever, you can communicate with us. And to learn more, okay, so about this, so there's currently an incentivization program on Ephemery that gives you an opportunity to contribute and also get incentivized for it. So, okay, let me not be fast to remove it. So in case you want to scan it, you can quickly scan it before I remove the slide. All right, so this is summary of the work that has been done and what is yet to be done in terms of client implementation. So that's for EL clients, and this is also for the CL clients. And for resources, if you want to learn more about Ephemery, you can check ephemery.dev. And to join the community, you can check the Ephemery Metrics community. And thank you very much.
All right, thank you, Glory. Any questions for Glory about her work on the Ephemery testnet implementations?
I wonder, is it something different to become a ephemery validator?
No, it's not. The same way you are a validator for that network, you can do the same for Ephemery.
So you still need 32 ETH?
So I didn't get that.
You still need 32 ETH? Ephemery. Oh, okay.
Anyone else?
Yeah, not really a question, just a comment. Like, a huge thank you. I mean, many thanks for all your work on Ephemery. Like, it's an incredible job what you've done implementing it and fully merging it and have it usable in both clients. It's incredible. Thank you so much for mentioning all the resources, the incentivization program, and yeah, like anybody can run a validator because being reset every month, Ephemery has infinite ETH for you, so you can just run as many validators as possible, maybe even more than mainnet at one point. But yeah, thank you so much, Glory. Ephemery was created basically at Devcon 2 years ago, and now after 2 years, it's amazing to see such an amazing job being done on the network. So yeah, thanks again.
Infinite ETH, you heard it here. All right, next up we have a presentation from Daniel on his network simulations with Shadow. All right, let's hear it for Daniel.
Hi everyone, thank you. My name is Daniel Knopik and I worked on shadow network simulations. Yeah. The usual clicker problems. Thanks. Yeah, so in my opinion, network simulations are awesome because they allow testing changes without rolling out to public devnets or even testnets, which is slow and takes synchronization and time. And small local devnets are possible, but with a software called Shadow, we can actually run huge simulations with thousands of nodes. And also with actual clients, like not any like code written dedicated to the simulations. So I kind of had a three-phase project. First, I wanted to prepare a tool that allowed me to easily set up these shadow simulations with Ethereum clients. That is easier said than done because Shadow can be kind of finicky sometimes, so it took a while. Yeah. In the second phase, I want to run experiments, specifically on PeerDAS and I don't want, also known as Gossip Sub 1.2. And in the third phase, I thought maybe if I saw in the experiments that this is actually a useful tool, I wanted to polish it and actually did, and thus ETH Shadow was born. So to sum it up, there are like two main artifacts from my project. The experiment results and ETH Shadow itself. In this presentation, I will kind of focus on my results from PeerDAS, and afterwards also show you slowly or quickly ETH Shadow. Right. So PeerDAS. I won't have time to explain PeerDAS fully, so I'm just going to assume there's some awareness of what that is. Few points. It's an update to scale blobs, and the basic principle is that we want to split the blobs into parts, which we call columns, with every node taking custody of some of those columns. And there are some network changes required for this to make sure that the nodes properly distribute the columns across the network, and also so-called super nodes can reconstruct the blobs if they have enough columns. And right now there's like 128 additional subnets in Gossip Sub, which all need to be covered by when a node wants to be proposed, right? We need to get every column out, so yeah. Okay, so I decided to run some simulations to help the research and development effort. Keep in mind that all results that I present here are like a few months old at this point, so the situation might be better at this point. So my simulation setup involved 1,000 nodes with Reth, Lighthouse, and Lighthouse validator client on each, with 4,000 validators, and in each experiment I simulated 45 minutes of simulated time. For a large simulation like this, we want to run on some server that is sufficiently large so that the simulation is fast enough for us. And I kind of experimented around a lot to make sure to get nice performance going, and kind of settled on a certain instance type. You can see it there if you want to run your own simulations with this size. And my simulations took around 4 hours per 45 minutes of simulated time. And so the cost per simulation came around at $10. Right. But if you want also run smaller simulations, you can also do this on your laptop. You don't need such a beefy server. This is just my setup for the PeerDAS simulations. So first I just tried running it on the current implementation in Lighthouse. And the simulated networks quickly fell apart because they lost sync and cannot really sync back up again. And that was kind of similar what was seen on DevNets at the time across basically all clients. So I thought about how do I measure performance, and I had several metrics, but right here I will focus on what I call score, which is how many slots can over 66% of the network stay in sync. And with the unmodified client, with the default configuration, 0. Immediately after we posted blobs to the network, we lost sync. But I also noticed that if I designate every node as a supernode, so custodying all the columns, not just 8 or 4, then the network stayed stable until the end. So I had the suspicion that something is wrong with the distribution of columns when we just don't broadcast all the columns at all time to everyone. And also that might be something with supernode reconstruction of the blobs might be wrong. Yeah. The investigation showed that the problem is that if a node could not send all the data out, it would not retry that at all, causing some columns to get lost, and custodying nodes for those columns would just not deem the data as available and would just not accept the block and lose sync. And they could not catch up. I guess the supernodes were not enough for that. So how do we fix this? I did some simulations where I varied the specs, and I did a lot of different variations. I will focus on 3 here. We could increase the number of peers, because if we have more peers, the likelihood that we actually cover all the columns when proposing a block with our peers is higher. So yeah, the base spec or the base configuration in Lighthouse looks for 100 peers. 150 peers scored 10 with the metric I just mentioned. 200 already 56, and 300 survived the whole simulation, so we could see that, confirming our theory, this improves the situation. Next up, I increased the number of columns covered per each peer, which should have the same effect, right? Because the total number of covered columns also increases with changing this. Increasing from 4 to 8 scored 10, and 16 already survived the whole simulation. Finally, there should be an emoji here, the diagonal face. Right, increasing the number of supernodes, which should reconstruct the full blobs, like all columns if they have half or more. Increasing to 10 scored 0 to 25 of 1,000, right? Scored 2, and 75 also 2. And at that point I didn't test any further because I want to kind of keep it in a somewhat realistic scape, and I'm not sure how many supernodes there will be, but we shouldn't, in my opinion, set the assumption too high. All right. If you want to know more about that, there are my weekly reports where I got into a bit more detail. So let's move on to the state of each shadow, like the tool I developed. Because seeing these simulations, I thought, this is kind of useful. I have like an iterative approach and can evaluate different configurations. So I spent some weeks in the end to make it available for everyone. And the source is available on GitHub at Ethereum/ETHShadow. Right now, there's like first-class support for Geth and Lighthouse, and there is some experimental support for Reth and Teku. There is some documentation left to be written. For basic use cases, there's like good documentation already, so you can check it out. And I think in some cases, usability can be improved. The hard part is that Shadow needs a lot of work for all clients to work in Shadow. The reason for that is rather technical. Basically, we need support for more Linux system calls in Shadow. And this is a lot of effort. Unfortunately, I kind of won't have much time. So I hope that in the coming weeks and months, I can at least help on the side a bit to maintain this. But I hope to also get the attention from the core devs to help me or help us all hopefully soon have ETHShadow for all the clients. Okay, there are some thanks to be said. First of all, thanks to my mentors, Adrian Manning from Sigma Prime and Pop from Ethereum Foundation Research, and also thanks to João Oliveira and Jimmy Chen from Sigma Prime, who supported me with some of their time. And thanks to Anton Nashatyrev from Consensus. He spearheaded the technical support in the last couple of weeks. Thanks to EPF organization, to Josh and Mario. Thanks to the Ethereum Foundation for hosting the EPF. And thank you to all the fellows. It was really pleasant and great to work with you all. And finally, I'm going to plug my talk tomorrow, or our talk tomorrow, simulating an Ethereum network at scale, which will go more into detail on how you can run these simulations yourself. So maybe see some of you there on stage 1 at 1 p.m. Thank you for your attention.
All right, any questions for Daniel?
Hi, just a couple of questions. One is, when you're making all of these changes to do these simulations, are you actually like updating the client code, or is it kind of like network configurations?
Yeah, this is like the great advantage to change these, or to test these changes. I actually can change just the client. I don't need to develop anything just for that. I change the actual client, but for like the things I showed you, I think I only needed to vary the configuration a bit, right? But I also did some changes that actually tried to fix these underlying problems in Lighthouse itself.
Cool. Yeah, and then I guess my other question, so are you starting simulations from like a genesis state, or is it like a fork of mainnet, and can you do forks of like existing networks?
Well, I start from a genesis state. My tool supports this. It just does this for us, which is nice. And forking mainnet, I mean, I'm aware that there are shadow forks. They are unrelated to the name of the simulation tool. I haven't tried it. The problem is that the genesis state is quite large, and this might actually be really hard to simulate like on a single node, right? We have all the simulation running on a single server, and that might be hard to have multiple clients in parallel working on that. So I guess it's not really feasible.
So I was wondering, like, once the simulation completes, can we see like consolidated metrics on the node or something like logs, something like that?
Very good question. This is how I evaluated those simulations. I kind of forgot to mention that here. The simulation, it is really easy to add a Prometheus node in the simulation configuration, and that automatically gets configured to pull the metrics from all the Lighthouse clients. And in the end, we have like one huge Prometheus database, which allows us to just pull up some Grafana dashboards or any other analysis. Also, we have all the logs, so we can also look into those if there are any like specific nodes that seem to be acting strange or something. Yeah.
In fact, you can see every log of every node. Like you can see the std out, you can see the std alert, and in fact, you can see every file that the node produces.
Right. You can also like run a node on a data directory that has been generated by the simulation afterwards. It's a bit weird because the simulation time always takes place in the year 2000, so it's really old data to the node if you start it right now. But you can run that node and you can attach like a block explorer or the explorer, for example, by the PandaOps team to it. It's just a bit wonky because of this timing issue. Yeah, basically, the simulation, Shadow starts the simulation time always at the 1st of January in the year 2000. So every time you do a Prometheus query or look into the block explorer, you have to keep in mind that you have to act as if it were the year 2000. Yeah.
Any final questions?
There are some up there.
Oh, we got one more. How is it different from kurtosis?
Okay, in a nutshell, kurtosis, you cannot run networks of this scale on a single server with kurtosis, because kurtosis is not capable of like pretending to the processes that time is running faster or slower than it actually is. Basically, like having a separated simulation time from real time. Yeah, I would say that is the main difference, that you can scale way higher with Shadow.
All right, thanks, Daniel. All right, next up we have another presentation from Hoppenheimer and Chirag, who will be talking about the rated list.
Hello guys, thank you for coming for the presentation. Okay, I think I by mistake clicked. So we are presenting the rated list. We were mentored by Dankrad on this project. It was his idea originally. What we did was to formally specify the rated list, take it out from a blog and have a proper set of Pythonic specs for the rated list. Build a simulator against which we can test the rated list, write some unit tests so that we have some basic sanity checks of the rated list so that it does not perform worse than just randomly pure sampling, and collect some metrics against known attacks on existing DSTs. So just to give you a quick intro to rated list, so this was the idea proposed by Dankrad, which is instead of having a DST, you form a tree of all the nodes that you know. You ask for, in kind of a pure exchange manner, you ask for nodes of the nodes, and you build out a tree, and you start your peer sampling. And based on the peer sampling, if a node replies or does not reply, you propagate those scores back to all the ancestors, right? So as you can see, the red node is a malicious node or a node that does not respond. And because of that, the scores of its direct parent and its great-grandparents are affected, right? So this is the basic idea of the rated list. This was what was defined in the blog. We went on to further define how you would use filtering over it, which is, scoring, yeah. So once you have every node's descendant score, so if a set of nodes are serving a sample, their descendant scores are not the actual scores that we use for filtering. What we do is we trickle, not trickle basically, but we kind of follow the paths of that node existence in all the subtrees, because a node has many peers and it would exist in different subtrees. We take the level 1 peers scores, which are the best for that node's path, right? So it's the best path score of that node. We use that score, we filter out using a threshold. If the threshold does not work, like if it does not filter out any nodes, we switch to an average score for the same. And basically because we want to complete sampling, even though we cannot filter out using the rated list. So that's average filtering. And after filtering, we can apply different querying strategies, which is we can use a random querying strategy, we can use the highest score first, we can use the lowest score first, and we can use the average score first. Average score first and lowest score first does not make a lot of sense in the start, but if you think about it, parent node can have a perfect score because none of its children are contacted yet, right? So highest score first wouldn't be the most successful strategy in some cases, right? You would want to go for the average score because you know that there are some honest nodes balancing out the malicious nodes in that subtree, right? So there are different querying strategies that we can apply. And for the rated list, we have defined a default score of 1.0, which is the perfect score, which is slightly optimistic, but it's fine because we do scoring on a per slot basis. So for every slot, we get all the peers of peers and build the tree, and we start scoring. And we delete the scores for the next slot. We start again, right? Ideally, what we could do is we could propagate these scores into the gossip score V1.2 to persist over slots. So we could have that kind of a scoring mechanism as well. Why do we use the rated list, right? The main attack that we are going towards is to defend against a local key space flooding attack through Sybil nodes. We also want to reduce the amount of requests that we sent out for actually completing peer sampling, which can be avoided if we can defunct an entire subtree of malicious nodes. I would say that the per slot tempo matches very nicely with the peer sampling requirements because you can have honest acting malicious nodes which is default on one particular block, right? So the entire objective is to complete sampling for that particular slot. So a per slot sampling sets the tempo right. And lastly, it removes dead subtrees. So if there are any inactive nodes, they would already be removed. And you could assume that we reach a global stability point, like where everyone removes their defunct subtrees. So then coming to the simulator and the simulator's design, we had to play around a lot because for graphs, there are libraries out there, but the ones that are usually used are not that optimized. So we started with the NetworkX library, but it was really slow at generating a random graph with a high degree at number of nodes at 10,000. Right now, for all our simulations, we use the degree at 50 and the number of nodes at 10,000, which is like a good assumption for a PeerDAS sampling network, right? And we use RushWorkX because, as you can see, the benchmarks for graph generation is just the best for all the libraries that are out there right now. And for querying strategy, we used all 4 querying strategies, highest, average, lowest, and actually random as well. But we also refilter nodes with a different threshold if we cannot complete sampling, because our objective is to complete sampling at the end of the day, right? So coming into the architecture of the simulator a little bit, we wanted to modularize everything so that this simulator can practically be used for other kinds of implementations like the rated list in the future. So having it modularized gives you an attack framework, because we have written a lot of attacks right now. So you could test against these in the future. So yeah, everything's modularized. We spec convert the rated list spec into a NodePy implementation for all the simulations. I'll give it to Oppenheimer. Sorry.
So yeah, that's the simulator. Let me just quickly. That's not working. I think it's working. Okay. I mean, just since the slides are off, let's turn the attacks on, I guess. So yeah, I'll quickly brief you guys about the sort of attacks we try to use against our construction. Okay, yeah, so basically what we try to do is poison the entire network with a lot of randomly picked nodes and mark them as malicious. The only problem with that is that the conditional probability of finding the parent being malicious with the children is almost same as just randomly picking any malicious node from the network. So just randomly marking any node doesn't make sense, and like there's not a lot of difference because of the rated list. Although the only attack vector that might cause an issue would be basically trying to attack on one local key space, and that's what we try to simulate. So yeah, basically trying to mark an entire subtree to a malicious node, which then gave us the results where we were getting far more better results in terms of rated lists as compared to just randomly. Yeah, there you go. Okay, so yeah, there's a graph plot where we get to see where the rated list performs much better than just randomly picking out nodes and trying to sample. It's in terms of the number of requests that go out. Like for 90% of 70% of Sybil nodes gives us almost double number of requests when doing a random sampling. But in case of rated list, it's like the lower number. So is it? Okay. Okay, got it. Should I? Okay. Yeah, so there are graphs showing those results, and there's some future work that needs to be done. We are currently researching on this new topic of trying to score the parents in a probabilistic way. Right now it's just averaging out. So we are trying to take the probabilities of each and every children nodes and then finding the score for the parent based on those scoring for the children. So yeah, that's the scoring mechanism we are trying to work on. And I mean...
Perfect, the graph's up.
Oh yeah, awesome. So yeah, this is what I was talking about, where we were just randomly poisoning the nodes in the network. You don't really see a massive difference between rated list on and off. So as you can see, like there's not a lot of difference, but there's a small difference, but still. Yeah, this is where we shine is the rated list performs much better than just randomly sampling from the network in case of 90% poisoning. So this is where there was a entire subtree marked marked as malicious, and I think I have a small, yeah, so those are the sort of future work we are trying to do, is that since our implementation is still in like super native, like primitive stage right now, so we would like to implement a better simulator, and yeah, I think this probably sums up our that's, yeah. Yeah.
So, did we, can you go back to the graph? So just want to point out that all these graphs were done over like 100 runs at different thresholds. Sorry. So all these metrics were plotted over 100 runs with different thresholds and different strategies tried out. And for the rated list, we picked the best score with in all among all different strategies, right? So best score first, average score first, and everything. Where the rated list off is just plain old naive randomly sampling from the network.
Probably just for visualization, this is the sort of graph that the big blue ball is basically a network, but then it's all pulled out, and those are the malicious nodes. Yeah. So yeah, thanks guys.
All right, any questions for these two on the rated list project?
Just trying to understand the Sybil graph that you had. So you injected lots of Sybil nodes into the tree, and how do you determine which ones were Sybil and which ones weren't? Or have I misunderstood?
Are you asking about the implementation detail or like?
No, kind of in general. So like.
Okay. So a Sybil node would basically not reply for any pure sampling requests coming to it, right? We can definitely test for more cases where the attacks are more nuanced, as in the adversary can be adaptive, where the Sybil node only responds to a certain number of nodes, but not other nodes. And if you want to actually eclipse a particular node, you would flood its local space and not just reply to that particular node, but reply to every other node. So, yeah.
So you were detecting the Sybils. You didn't just assume that they were Sybil, right? You didn't just say these ones are malicious. You actually, based on their responses, you determined that they were Sybil attacks.
Yes,
cool.
yes, yeah.
Yeah, the parent-child relationship that you showed in the graph, like how do you come up with the peer parent-child relationship? Is it like if this peer like told you about the other peer, then it's its child?
Yes, so it's much more of a local view rather than a global view, where it's basically just like peer exchange, where we just ask for peers from particular node. Like, so first I ask from the nodes that I am connected to for their peers, and then I make a list of those peers and ask for peers from them as well. I can cap this, basically in the rated list, we have it capped at 100 max children per node. So any node could like randomly send for every slot, randomly or maybe probabilistically send a certain set of 100 nodes to us.
Is this a candidate for like replacing CAD-based discovery?
It wouldn't replace CAD-based discovery per se. It would. So rated list assumes that you already have a libp2p network. And for discovery, it's not really like you would need bootstrap nodes to actually form this thing. So it becomes a little more complicated over there. But yeah. But what we are definitely planning on is, like, if you think about it, per slot scores, they make sense if you assume that malicious nodes are honest acting until that slot. But then you can also have malicious nodes that start acting honest after that slot, and a per slot score wouldn't really help at that point. So, but the good thing is the version 1.2 gossip scoring provides like these application scores that you can inject into them, and they are persisted with DK parameters and everything. So we plan on just injecting the rated list score into the gossip V1.2 scoring. Yeah.
All right, thank you. Let's give it up for these guys one more time. All right, next up we have a presentation from Gilia, and he is going to be talking about his high-performance SSZ implementation.
Hello, my name is Gilia. I'm here to present my work on SSZB, a high-performance SSZ implementation in Rust, as well as my work on SSZ Arena, a benchmarking suite for the crates in the Rust ecosystem. My motivation for working on this project was having a chance to work on optimizing an existing project, which I haven't done before, and so I learned a lot in doing this, as well as seeing what kind of gains were possible in something like SSZ. It's not a real bottleneck in clients today. It's still a fairly simple task, but I was curious about what kind of losses were present over a long periods of time if without an optimized implementation. And so I thought this work was very appropriate for the fellowship because it's, I guess, lower priority for client teams, but still work that needs to be done. So I'm briefly going to talk about what serialization is in SSZ and go over the SSZ ecosystem, as well as my work on the benchmarking suite and the implementation, finally talking about performance and next steps. So zooming past these first few slides, serialization is the process of transforming a data structure into a common format that the different clients can agree on, which is important for consensus. Normally, data structures can't be transmitted as is because of different in-memory representations and such. SSZ is the serialization scheme on Ethereum 2 meant to replace RLP on the execution layer. It has a few improvements like schemas, which are a must-have in a performance system. And Merkleization is the process in which we generate a short digest of the state while allowing for updates without rehashing the entire state. This is useful to generate small proofs of the contents inside a beacon block for light clients that don't want to hold too much state data. There are a few SSZ implementations in the ecosystem, mainly in Go. Fast SSZ is the most popular one and used in Geth today, although Peter also has an implementation out. In Rust specifically, there's Sigma Prime's Ethereum SSZ, Grandine's crate, which isn't public and is only used internally, and Alex Stokes's crate, SSZRS. For the first half of the fellowship, I worked on a benchmarking suite to evaluate how these libraries perform against each other. Most of these crates have tests on consensus spec tests, but there's no real way to see how they perform on real data like beacon blocks and beacon states. So I worked on a library, not library, a project called SSE Arena, which benchmarks the different crates in the ecosystem. And so it evaluates it on more controlled test cases like lists of integers and validator structs, and also evaluates it on blockchain data like beacon blocks and beacon state that I obtained from a beacon chain checkpoint. So I leverage Criterion for this benchmark suite, which gives us handy reports. But I also use another benchmarking library called Devcon, which handily gives us allocation stats, so we can see how much memory is being allocated during these encoding and decoding runs. And so this gives us a robust way to measure performance. Now on to the second half of my work in the fellowship, working on my own implementation. So how does one optimize SSE? Optimizing this serialization scheme and benchmarking is kind of tricky because the real bottleneck or most of the optimization in encoding and decoding is simply using a more optimal data structure. There's a lot of techniques you can do to optimize this. You can lay out your data in memory so it's aligned to the word boundaries, and there are other techniques like zero copy deserialization where you can simply cast your bytes into your type. That's only really possible when you have control of the underlying data structures, which I did not have for this project. And there's a lot of reasons why you might not want to just rewrite your types with serialization in mind. Sigma Prime, in particular, has done a lot of good work with their Millhouse crate, which allows for faster sparse updates of beacon state. And so it doesn't really make sense to just change your type, that crate, just to speed up serialization. It's better to just think about how to work with the types we have. And so being constrained by the inability to change the underlying data structure, I opted to minimize intermediate allocations. And so a second bottleneck in serialization is how much memory are you allocating in between steps to serialize and deserialize. And so here's how I went about my implementation as a ZB. It has two main differences. It uses the buff and buff mute traits. This is an abstraction over buffer types, so it encapsulates both vectors and slices, and has the added benefit of abstracting offset counting, which greatly simplifies the implementation. So for context, you can outright define how to encode and decode certain types, but the SSEB package also provides a macro for automatically generating implementations for container types, which are like structs. And so generating these implementations is a hassle. We provide a way to do this automatically, and the implementation for it is very simple thanks to the buff mute traits. And second, we avoid a lot of intermediate state during the encoding process and minimize any needed allocations during the decoding steps. This reduces the number and size of memory allocations needed to perform serialization, which is another dominant cost, as I mentioned before. Peter's Go implementation, SSE implementation does this, and Grandine was also another big inspiration. Although, to note, Grandine only works with slices. The benefit of using buff and buff mute is being able to use vectors and any other buffer implementation you want to provide, as long as you implement the trait, which I'm not quite sure how it's going to be used just yet, but could be handy. And it performs pretty well. So I tested this on beacon block, decoding and encoding. It's pretty fast on the decoding part. If you'll consult the graph, I'm not quite sure how visible it is, but we're clocking in at around 129 microseconds on the decoding part versus 3 milliseconds in Ethereum SSE. And while the differences aren't as drastic for all types, we're getting there's similar levels of performance, around 85% encoding speed up and 95 decoding speed up on the beacon blocks. So that was for the beacon blocks. There's still some changes to be made, some fixes to be made for beacon state encoding and decoding. I know there's a bug in the implementation. I know where it is. I'm going to go fix it, but I only found it like 2 hours ago, so didn't really have time to fix that today. As for next steps, I want to ship support for Merkleization and Merkle proofs with generalized indices. This is needed to have a full-fledged SSE implementation. My focus for this fellowship was on performance of encoding, decoding, and so I left this for after the cohort. Additionally, I'd like to support a new trait I call SSE check, which provides early input validation to check that an input conforms to a certain type. This would be useful if you want to reject malformed inputs earlier instead of having a full decoding step in the hot path of your application. And then after that, stable release. I want to gear up for a stable release, adding usage docs and cleaning up anything that needs to be polished in the library. And then once that's done, I want to work on something I find interesting, but I'm not sure if other projects would want to use this. But I think it'd be cool to have support for partial encoding and decoding. For example, for large objects like beacon state, fully decoding can be very expensive. And so partial decoding would drastically speed things up, especially if you only need a subfield of your beacon state. And re-encoding and rehashing would work similarly. Again, with the Sigma Prime's Millhouse implementation, they're already implementing their types with sparse updates in mind, and I think SSE could use some similar ideas with regards to sparse updates. I'm a little over time. I want to thank my mentor, Michael Sproul, from Sigma Prime, who did most of the work, I believe, on Ethereum SSE. He's not a Devcon, I think. But if you're watching this, thank you. And I also want to thank Josh and Mario for providing the opportunity. I learned a lot through the cohort, and I'm glad I got the chance to do this work. Any questions? That's all for me. Yeah.
All right. Any questions about the SSE library?
Is it ready for clients to switch over to?
Not right away. Probably after stable release. I forgot to mention also that there's no unsafe code in this, so it's Michael told me not to use that. Yeah.
Coming soon.
Yep, coming soon.
All right, one more time for Gilia. All right, our final presentation for the afternoon is from Yash, who will be talking about his explorations into single slot finality.
Okay, so hello everyone. Really appreciate all of you coming here today to listen to this talk. And in this talk, basically, I want to talk about the state of dynamic availability, the state, basically what has been going on in the industry and what I have been, working on for the past few months on this. So basically, I started the fellowship by basically understanding like consensus algorithms and looking into single slot finality. But as the time went on, I basically focused more on dynamic availability in particular. So for starters, definitely the question is, what is dynamic availability? So it is basically any protocol that is live under what is called dynamic participation, which means that basically nodes can come and go into the protocol, and it still works. It's not like a static validator set where the protocol is already aware of what nodes there are. So like this dynamic participation. A few examples is definitely the Nakamoto consensus, like Bitcoin, LMD Ghost that is used in Ethereum currently, and a few other protocols that I will be talking about today, like Goldfish and RLMD Ghost. So a little bit primer about LMD Ghost, if anyone is unaware. It is the fork choice rule that is used in Ethereum. It basically uses the weights of votes to decide the tip of the blockchain. So like if there is a block proposer and it wants to propose a block on top of a previous block, it calculates all the votes that basically any particular tree has. And so as you can see in this diagram, perhaps that the block F has 20, E has 25. So like when you are at A, you're gonna take a step at C because it seems to be like the heavier subtree, and then you can take a step at E, and that way you can decide which block to choose as a tip. Now, currently, LMD Ghost as it exists has some problems. It has problems with dynamic availability in particular, and it has a problem with reorgs. So a particular attack vector that I want to talk about is an ex-ante attack. So how to execute it? So let's say you have a block at slot n, and then it's time for slot n plus 1. Now the validator here is malicious, and it proposes the block, but it does not releases it into the network, and it has control over a set of malicious attesters that attest to the block privately. So for the majority of the network, they think that the slot is empty. So in the next slot, when a new block is proposed, they tend to vote to that slot. But as you can see that in the next slot, the malicious proposer then releases it to some of the network, and then some of the attesters might see block n plus 1 before the block n plus 2 and then attest to that. And then this cycle can continue in for as many slots as the malicious proposer wants, if it has some sort of control over the network delay. And then it can release the entire thing to the network, and as more and more slots a part of those slots attest to this malicious block, it gets more and more weight. So if it then releases a new block that is tied directly on it, you can see that the weight of the n plus 1 block would then be more than the other blocks. So the chain will then reorg, and that's how basically honest proposers blocks will not be included in the canonical chain, because the chain has reorged, and that is obviously an undesirable property. So how do you solve this? Well, there is one approach, and that approach is basically Goldfish. So Goldfish is a protocol which As you can see, like whenever the slot is, someone proposes a block, they vote. The attesters basically vote for that block, and all those votes are then aggregated, and that's how the tip is. Like what Goldfish basically does different from LMD Ghost is what's called like vote expiry and vote buffering. So vote buffering is basically, like whenever you see a block, whenever you send a message into the network, that network messages are called like vote buffering. And it's also called view merge. So like by view you mean like you view something in your local view, and by merge you mean that you merge what you see into what you think is the current state of the network, because you as an individual validator cannot know the state of the entire network. You only know what your local view is by the nodes that you're connected to. The thing that it introduces, it's vote expiry, and that basically means that it does not uses the votes of from the previous slot. So it only uses the votes that are casted in this particular slot. So previous validators basically, if they vote on something, if there is some sort of if they're trying to withhold votes and they publish it later, then it will not be counted. So that way nobody can withhold votes, and they will not be counted, they will be discarded, so you don't have attacks anymore. But it does raise another problem, and that's the problem of asynchrony. So what if there is a network delay, right? Because if a validator basically votes for a block and the vote does not reach in time in the particular slot duration, then that attester's votes will not be counted, and that is not the fault of the attester. It's just some network delay, it's just a period of asynchrony, right? And the Goldfish protocol would just not work in asynchrony. So that's a particular problem that it faces. Another way to think about the reorg attacks is to think about subcommittees. So subsampling or subcommittees is basically crucial in the success of these reorg attacks. And because it is easier to like have a control of a small set of validators, and easier to have like control over the network delay, if there is like a committee, because like a committee has like 30,000 validators, but like the entire set of Ethereum has like 1 million. So like you cannot have control over the entire network. But it's practically like somewhat possible to have over about, let's say, 30,000 nodes. So like if you just remove subsampling completely, and you just have like the entire 1 million validator set attest in every slot, then well, the problem of reorg attacks will be solved. But I mean, obviously that's not practically possible in like 12 or 13 or like so seconds. It's gonna take a long time to get all those votes, get the aggregate the signatures and stuff like that. So RLMD Ghost, which is like a version of this protocol that I'm describing, introduces a concept of relaxed vote expiry. And that is basically what I mean by relaxed vote expiry is that in Goldfish, you remember, the votes expire by after just one single slot. But in this, you can basically balance between asynchrony resilience and dynamic availability. What that means is that you can basically choose the votes from the most recent n slots can be considered. And the reason I say that it's a balance is because dynamic availability basically means dynamic participation. Like validators can go in and go out, and like if a validator like is part of the network, votes, and its votes is either withheld or like through network delay it's stuck, and then the validators go offline, the vote can still affect the protocol, which is not a property of dynamic availability. So like Goldfish is a perfectly dynamically available protocol, but through RLMD, by choosing this parameter, you can balance between both these factors. But as you see that it also has a problem of not having subsampling. So is there like an impossibility between these three properties, reorg resilience, subsampling, and asynchrony resilience? And the answer seems to be yes. Like I didn't get a chance to work particularly on a formal proof of this relation, But based on what I have studied and researched so far, it seems to be the case, because if you think about it, in from a view of a validator, if you do not receive an attestation from another validator, there could be two reasons for that. Either that validator is malicious or adversary and it's withholding the vote, or there is just a network delay. And you as a validator cannot differentiate between the two. So is there a way to basically combine all these properties together in a fashion that can be useful for the protocol? And well, a disclaimer: this particular slide needs to needs a lot of academic review and a lot of validation from people much smarter than me. So just take it with a pinch of salt. But a possible solution could be that we can use Goldfish as the current as our fork choice algorithm, and we can try to figure out a way to deterministically identify a period of asynchrony. So let's say that a committee has 30,000 votes. Everyone votes for a particular block. So there are around 30,000 votes per slot. And if let's say the number of votes drops suddenly, that could be a condition of asynchrony when the protocol will dissolve the committees and shift to an RLMD model where the vote expiry period will get relaxed, it will expand, and network and the votes from previous networks will then be allowed to be considered into the fork choice rule. Then based on how quickly the votes are coming in, we can determine if synchrony has been achieved again, and then we can re-establish committees, and the protocol will be back to normal. So that is roughly it about the talk. I want to thank the Ethereum Foundation and Mario and Josh for giving me the opportunity to study about this. And I also want to thank my mentor Francesco, who's doing consensus research at Ethereum, and also Lincoln, who was the Ethereum fellow in the last cohort. He also worked on single slot finality. So yeah, that's it about my talk. Thank you.
All right, thank you, Yash. Any questions for Yash?
So I'll raise one. It's just, if you're swapping between modes, do you think that increases the complexity of your vulnerability and attack surface analysis? Because what starts happening is that a malicious attacker can influence the network. So you switch from one mode to the other, etc., so that they can take advantage of that situation, etc. And amongst other things, that just makes it much harder to reason about it, and people can forget that actually the network's not always operating in this mode. They need to consider that it changes.
Yeah, of course. So basically the model that I talked about is obviously if we do more research on it, it's going to be incredibly complicated, and switching between basically consensus protocols on the fly is going to be very difficult. The reason for my research is just exploring what are all the possible designs that can be implemented into the consensus. And of course, Ethereum itself is moving more towards the single slot finality model. So it would be interesting to just see how dynamic, what are the properties of dynamic availability, and how it could be. Obviously, this is not something that I would propose to actually put into Ethereum, but it's still interesting to research about it.
All right, thanks, Yash.
All right. Thank you, guys.
One more. All right, that concludes the presentation portion. We will have a panel with a few of our previous fellows who are now working either on client teams or in other granted positions. So give us just a minute or two to set up for that, and we will get started.
Hey, everyone. We'll be starting our panel in 1 minute. If you can join me, my fellow panelists. Yeah, feel free to sit. Okay, I guess we can start. We're already a bit late, but we've managed finally to get all the panelists here. So, yeah. First of all, thank you so much for being here, all the fellows on the panel, and all the fellows and attendees and mentors who managed to make it to the end of the EPF Day of 2024. And we are wrapping up today's EPF Day with a special panel discussion, and I called it the E-panel discussion because it's Ethereum, but it's also Echo, Ethan, and Anico. Completely randomly chosen fellows, of course, to join us. And so I chose you guys, I invited you guys, because all of you have been in previous cohorts of the fellowship, and today you became full-time contributors, you became working with client teams, or actually like, so I will start with a quick intro, and I will kind of do your intro. You can add if you want something, because I want to move to the questions. But so we have here 3 people who have, who I believe are representing all kinds of possibilities that EPF can give you, because we talk a lot about client teams and the core contributors and so on, but not everybody from EPF is going to end up working in a client team, and there are other kinds of futures for you. And I will start with the lady here, Anico, who's been working on debt packaging as a part of created verifiable deterministic builds for Ethereum clients, and has been working on it for more than a year now as a grantee. So continues her EPF work on a grant and working on something which is Ethereum tooling, but not directly to the clients. So great example of like how people from EPF can work outside of clients. We have Ethan, who is on the other side, directly in the client, working full-time in Lighthouse as a core developer. And we have Echo, who is a researcher in ARG, or Applied Research Group in Ethereum Foundation. So we have also representative of a research fellow. So yeah, all kinds of backgrounds. And I don't want to actually like talk really about your EPF experience itself, because you can actually find it, right? If you go to Cohort 3, Cohort 4 repository, all of the experience, all of the work done by these people is there. It's open. You can read their story for week by week, basically. So we don't need to dive into that. But I want to ask you folks, looking even before EPF, before you started diving into Ethereum, diving into the fellowship, what was it like? What did you think at the time? What brought you to the EPF? What was your like initial motivation to start working on this? What interested you? What was the initial push to get into all of this, whether EPF or Ethereum? Yeah. See, whoever wants to start.
So. I mean, I got into Ethereum or blockchain originally because I saw my friends use Aave. They took out a collateralized loan in like a minute, and we're moving money around, and I'm like, what is this? Like, how does this work? I don't understand this. And then they got liquidated like a week later, and I'm like, oh, this is really cool. Like, I want to learn more about it. And then fast forward a couple years, I got a job in like Web3, doing like app development. And I came across the EPF actually during Cohort 3. It had already started, so I was just kind of like peeking around, seeing what's going on. And I think the merge was happening at the same time. And when the merge happened, like one of the main things that I noticed was like how it just worked. Like there was no issues, no bugs, which is kind of like a crazy concept. I don't know if you guys play like video games. Like I used to play World of Warcraft a lot, and every time there was a new expansion, the servers would crash like day one. There was always an issue. And for this like huge distributed system that multiple teams worked on, previously I didn't even know that there was multiple client implementations either, which like kind of tripped me out as well. And so, you know, seeing all that just like really impressed me, and I wanted to learn more about that world. And then, you know, Cohort 4 came along. I had already made a couple small PRs to Lighthouse and interviewed, and yeah, got in that way.
So you know that Ethereum was created because of World of Warcraft.
Yeah.
Yeah, I mean, literally, yeah, it still keeps producing core dust. It's amazing. Yeah. Any echo, yeah, whatever.
So what got me into blockchains? It was a few years back whenever I was in the tail end of college and I was not really, like, was super lost, and all of a sudden, like, COVID hit and I kind of saw a lot of institutions and like systems that were super fragile and like all of a sudden broke out of nowhere, even though there was like this veil of legitimacy that was kind of shrouded amongst all these things that ended up breaking. And I saw technology as like, and blockchains as like a way to kind of help build more robust systems to coordinate humanity, and thought it was really cool. And so I just started tinkering with like, I was building some light client that ended up like, it was ridiculous looking back, but like it kind of got me in the door. I met a client developer. He told me about the protocol fellowship, and so yeah, that's what happened. And I applied, and y'all said yes. So thanks.
So word of mouth helps to run fellowship, all the time.
Yeah, dude. Yeah, and I think like a big thing was interacting online. With people in the Ethereum Discord, and like you can find these people online, and a lot of them are like really kind and are super excited to help anybody who's interested. So
yeah, so for me is I'm living in Thailand, so I moved here like a decade ago, and I live in Chiang Mai, which is, I don't know if how many of you went there to do a short visit. It's basically a crypto city, so Bitcoin is a very, very heavy dominant there. And I was always like, oh, I don't really want to get into this because it's just all these crypto bros, and they just want to do with all this new token and everything. So I was like, no, I'm opposing to. But near COVID, I started working in a co-working place, which is like a blockchain space, and there was this guy who was doing Chiang Mai dApps, and he was hosting a blockchain meetup, and my friend just convinced me to just go once. So I went, and I was like, he was showcasing Uniswap and stuff like that, and I was like, wow, these are really, really cool stuff. Like, I was like the first time that I'd actually see projects that are trying to make an impact, and at the time we didn't have the word for refi, because that came a couple of years later, but I was like, oh, this is like, people are actually trying to build something that is very decentralized, but also like, also makes money for the people. So it's like, for me, this was the initial thought that made me wanted to be a programmer. So it was like, I was really sad for a very, very long time that I couldn't really find all of these projects. And I was here out of nowhere just after the COVID. And yeah, so that's where kind of my journey started, and slowly, I get it more and more involved. And did the EPF last year, which is like, also was crazy because I applied like, I think a week or 10 days before, I think less than then I was like, oh, I'm not getting in, I'm just applying, so I actually went to in Cohort 5 or something like that, and I got accepted, so yeah, that's a story for me.
So where did you learn about EPF?
Yeah?
Where did you learn about it? Where was it coming from?
EPF, so I actually know one of the previous fellows from Cohort 2, so that's how.
Right. Yeah, so again, word of mouth and community, it's like fellows bringing more fellows all the time, yeah.
So yeah.
Please bring more fellows next year, yeah. Yeah, thank you so much, everyone. Yeah, that's lovely. So yeah, that was before the cohort started, and now I'm going to skip the cohort because, again, it's all on GitHub. You can read the experience, and we discussed like how it helped you and so on at the EPF days before, but now I wonder like what happened for you since then. So it's been like 1 year for you folks, 1.5 years for Echo since the cohort ended. What is your biggest revelation since then? What was some highlights, some biggest progress you've made, some revelation you had since working without the training wheels of EPF, basically. Yeah.
No. Okay, so stays here. So I'm still working on the project, and I'm working under the ePBS, so I'm trying to simplify node ordering, but also providing packages for Linux. And it is a pretty complicated project, so there's a lot of moving parts. I got a comment that my project is I don't remember the word, but it's too much, so it should have been just exactly the smaller one. Either way, one of the stuff is like just keep going and keep doing, and things start to work out, and it just takes time, more time than you would originally thought. But it's still it's just be patient and persistence, and things going to work out. Yeah, for me that was.
Yeah, I mean, one of the biggest highlights so far being a core dev was being able to go to one of the interop events. So it was about, I don't know, 6 months ago or something. We all the client teams went to Kenya, and we spent a week kind of at this resort, and we all just kind of were stuck in a room together and worked for a week. And for me, it was a really cool experience. One, I got to meet a lot of my team members that I'd been working remotely with, and two, I got to interface with researchers, the other client devs, people that have been working as core devs for years, people that I respect, that I look up to. And I was sitting in the same room with them, having conversations with them. I probably learned more that week than I'd ever have about blockchain any other period of time. And it was such a cool experience. I tell everyone I felt like I was the dumbest person in the room, but in a really good way. Like, I felt like I was able to absorb so much, and I felt just like so lucky to be there. It was really, really cool.
I guess the biggest thing that I learned, like going off of this like dumbest person in the room thing, is that I got really scared a lot of the times whenever I was interacting with these core developers, and shied away more than looking back, I wish I didn't shy away so much. Like I didn't ask questions that I had, like I was thinking, because I was like, oh, what if someone thinks I'm stupid or something like that. And that's recently started to change, but I still feel that part of me that's fearful. And I don't know, you can't don't operate out of fear, because that shit sucks. It's really not a good way to go through life. Yeah.
Yeah, thank you so much. I mean, it's all great advice, whether it's working hard, whether it's, don't be worried to ask questions. Yeah, that's amazing. Because that was kind of my next question, asking about some advice, or maybe something from the perspective at a time when you were doing or finishing the cohort. What is something you wish you knew at a time? What is some advice you would give to yourself at a time when you were still just starting, something that would make it easier for you, with considering your current experience? Yeah.
Sure. Yeah, don't operate out of fear. That's definitely a big one, and I think trying to keep the North Star, whatever is driving you forward, your own internal North Star. I know this is a meme that's been going on, but have your own, and yeah, don't forget it whenever you go super deep into the technical, the weeds of things, because it's really easy, or at least for me, to go super deep into something and forget where I was. And if you kind of forget where you were, then it's easy to not remember 3 months down the road, oh yeah, what was this all tying back towards? So.
Yeah, I think one thing I told myself towards the end of the EPF is regardless of what happens, the 4 or 5 months that I spent were so valuable, and I learned so much. I became a better developer, that regardless of what ends up out of it, I know personally I grew a lot as a person, as an engineer, and I could take that anywhere else, even if it's not in Ethereum. And on the other hand, I also was dedicated to being very persistent. So I kind of told myself I'm gonna keep opening PRs at Lighthouse until they have to hire me. I wasn't gonna give up. And so those were kind of the two things that I had in my head, and they made me feel, I wasn't like too stressed about it because I knew that regardless, I gained so much out of it that it didn't matter what was going to end up happening in the end.
I think I have this question before, so I think the same answer. As I said like a year ago, it's like just talk more with the people. Like I feel I didn't really interact so much with the people, and the people are so helpful. Like everyone's like from the EF and all of the teams and so on and so on. And maybe they don't have the time to reply to every PR or every question that you have because they are busy and they have, I don't know, like Lighthouse, I think they have like a tons of PR there or question issues. So it just takes time for people to reply or just even understand. I think I opened the PR on one of the clients and they're still working on it because they are just so much overwhelmed with all the tasks and all the roadmap. So just be really patient and interact more and then don't work in isolation, because for me it's like, oh, I can just do it alone and I can do everything. And that's true, but I think it's when I get the input, I can get out of these rabbit holes that sometimes I'm really dig myself into, because it's just somebody just says to me something in like one sentence and like saves me 2 weeks of work. So that happens a lot. So that's just really good for me. Yeah.
Yeah, awesome. Thank you very much, Nico. Yeah, it's all amazing advice. Very inspiring, all of you guys. I hope to use you to inspire and motivate the current fellows at because it's I think it's maybe a bit tough time at the end of the cohort when you kind of don't know what's coming next, right? I also wanted to ask about that, like what was it like during this transition period? Before I get there, I want to check if there are any questions from the audience. I want to also give you chance to ask questions, and I can just continue asking my stuff, but you are here with these people. I want to give you the opportunity, same like the office hours, right? Don't be shy, classic, right? Dan is missing here to drive it. Oh, we still have Katya, she's the runner-up. Yeah, we have a question already. If you have questions, please feel free to raise your hand. We'll give you opportunity. Also, there are 3 people with 3 very different expertise covering like most of the EPF, core protocol related stuff, so feel free to direct on the individuals or the whole panel. So if you have questions, always feel free to ask. And if there are any or not, I can maybe continue, but okay, Katya, go ahead. I want to save mine because we still have time, so.
Hey guys, thank you for coming. I just wonder, how long was your cohorts? How long? How long?
How long was?
The cohort.
The cohort?
Yeah.
4 month
the guys.
cohort. Yeah.
The same?
4 months.
It was before it was used to be 4 months, and it was running echoes from the cohort 3, which was the first one that we did with Josh. So also for us it was a new thing, running from like November till February, 2022 till 2023. And then in 2023 we started the cohort 4, where Aniko and Ethan participated. Yeah. So.
Yeah. Thank you.
Yeah. Yeah. So yeah. Jeziza.
Hello, I'm Jasvisa, and I just wondering, what's the working experience as working for Ethereum and for other companies? Yeah. So what's the working experience different from working for Ethereum and for other companies?
Oh, yeah,
the employees for Ethereum Foundation is very stable, and but for other companies maybe is
Yeah, because you folks, again, you have very different experience. So maybe like, what is it like working on a grant, working for a client team, working in EF, and maybe if you have other experience from like corporate kind of normal businesses, like if you can compare that, yeah.
Yeah, I mean, I've worked like in the healthcare industry, e-commerce, and also like Web3 app layer, and those were always like very like product focused, very I guess like very like we had like a product manager, like we need this feature, or if that site is down, like you better wake up on a Saturday and like do this. And so working on like open source software, like Lighthouse has been kind of like the opposite, where you like, obviously there's things like Pectra, like the upcoming upgrades that we kind of have to do as a client team, but we also have a chance to like explore maybe ideas that we have or work on things that interest us. And everyone on the team is also like very passionate about Ethereum. Like, when I worked in e-commerce, I wasn't passionate about e-commerce, so it's really cool to like work in a field that you also like care about in your personal time. Yeah, I get, and then also like, not just that, I get to interface with other client teams and other researchers that aren't even part of our company, but we're all like collaborating together, which is very weird. I had this discussion with someone about, the different client teams, like let's say Lighthouse and Prism, and he says, is there competition between Lighthouse and Prism? And I said, no, like, we care about client diversity, like, we want, a healthy, diverse network. And they just couldn't wrap their head around it. They're like, what do you mean? Like, you guys like don't, compete or hate each other or whatever. And it's like, no, we literally collaborate. Like, as I said, we spent a week in Kenya, like talking, sharing ideas, learning from, each other's like implementations or whatever. So it's a totally different paradigm than I was used to in, other jobs that I had.
So I didn't have any sort of real job before working at the EF, and that's definitely, it has its pros and its cons, but yeah, there's like a lot of room for you to kind of explore what it is that you want to do as a researcher, at least. So there wasn't much structure at all, and you just kind of go off and figure out what's interesting to you, and you explore that, and it's on you to like reach out to others and try to learn from others, and it's on you to like hold yourself, like to set goals for yourself, and like to make sure that you're staying on the right track and progressing the concept that you're exploring or whatever. So that was very interesting, and I think there's some organizational changes happening, so it's a little less. I think we're moving from this like super free-formed research group to kind of like slightly more directed. So that's changing, but yeah, that's how it was for me.
All right, so I think I have quite a diverse experience. So I was working for both corporations and for startups, also for Web3 and non-Web3 as well. And this is like basically kind of like my own company in a way, because I'm saying my own company because I have to do the development, I have to do the project management, I have to do the marketing, I have to do the community building. So it's like, it's a lot, and it's like, it's really like wearing a hat, like which hat you are wearing in different days, and it is just, I cannot do like coding on the same day and do marketing. So then I'm trying to like make each day different. So when I'm just on Twitter, or I'm still not though, I'm trying my best. So it's I think it's very challenging to do a project like this kind of size that I'm actually started under the EPF. And I'm still in many ways I feel lost, so I'm really happy to be here in Devcon and meet people and get feedback and advice, or see how people are actually doing different projects. I think it's really rewarding, so it's definitely something that I really do love to do. It's just tons of work, and if something breaks, and I'm actually supporting all the clients, which is like 10 at the moment, and will be with Grandine will be 11. So it's every time they just push an update, like on Saturday, like Lighthouse, I had to just go and then do the release. So it's like, okay. I mean, it's on them. It's like, sure, why not? But it's like have all the processes done, so I don't have to be there and do all this. So it's really kind of like building up all of this, so I can free up my time and do development work, which is what actually matters. And it's challenging, but also very rewarding, I think.
Yeah, thank you so much, Nico. I mean, it's yeah, very hard task to manage your own project independently, but yeah, a huge respect for also working like this. And you guys are pushing releases during Devcon, like you're working Like, how is it even possible? Anyway, yeah, thank you so much, everyone. Yeah, audience, like, feel free to, yeah, I see some hands there, yeah.
Sorry, good afternoon, everyone. So my question is, I had a project, and it had something to do with Lighthouse. So I found it difficult to navigate through Lighthouse. So I really want to understand, how do you guys maintain the code base? Because the code is kind of like much compared to grinding. And it's more like there's a file that has like up to 6,000 lines of code. Like, whenever I look at the code base, I find it difficult to digest. Like, how do you, as a developer, how do you navigate through so much code base? How do you maintain? How do you test and all of that?
Yeah, I remember when I first looked at Lighthouse, I also was sort of new to Rust, and I was pretty lost and overwhelmed. And I think that happens a lot, like in general, when you look at new code bases, like when you started a new job, you know, you have to learn, you know, the infrastructure, the business logic. And so what I really tried to do is like start small. So I picked like the easiest PR I could find. I think it was like to like update a log message, like literally like a one line. It was just like changing like a string or something. It was really silly. And then I took another PR that was a little more complicated and just started building on things. So instead of like trying to do something big at first, which would have been like really, really overwhelming for me personally, because the way I learn, you know, everyone learns differently, but the way I learn is like by doing things. I just started with like the simplest PR, you know, issues I could find, and built myself up from there. And Lighthouse is a really complex code base. There's a lot going on there. I mean, I've been working at Lighthouse for almost a year, and there's, you know, things in the code base that I'm not, you know, super familiar with, and I'm, you know, learning to this day, and I'm sure even a year from now I'll be learning. So yeah, there's a lot there. And you know, we are on Discord, so if you have questions, yeah, you can message us on Discord. We're super responsive, and we can try to help. But yeah, it's definitely a lot. It's not a. I also had trouble at first, for sure.
Claude helps. Like, genuinely, it's getting good now, but like, you can just highlight everything within the repository, and if you have a question, highlight the repository, and then ask the question like, all right, how do I, like, where do I start? And these days, it's pretty good at like, it kind of knows the protocol pretty damn well and like understands Rust, the language, pretty damn well, and it can definitely point you in the right direction.
That's an interesting hack, yeah. And Aniko, feel free to add like navigating, or like maybe to reframe it from your perspective, because you were so not diving into like existing big code base, but you were starting from zero, but a very complex project. So when you are starting from zero, where do you start building something such a beast?
I have to patch kind of a few clients on my project, so because not all of the clients are allowing for reproducible builds, so it's like 5 or 6 languages that I have to be in some ways familiar with. So it's just basically they put the build ID a year, sometimes something else. So it's breaks. So I have to re-dig through why it's not working. So it was really challenging to like, yeah, but I think it can comment that it's, and also it calls it, it's just start small and keep building on it, and small things done over time. It's like has like people like always say, when you save money, do the compounding interest, and it's in 10 years, you know, like you will get rich. And I think people don't use it enough for development purposes, because I think that's how it works. And I think that's why Ethan got hired by Lighthouse as well, because he started very small and keep building up onto, and it became very big in the end. So I think it's just start small and definitely do PRs. Like, I think small PRs, start with small PRs, and you build it up.
Yeah, that's awesome. That's a great advice as well, compound effect, yeah. Any more questions? Anything from the audience? Feel free to ask, generally, or yeah, Gilia?
Thank you. I had a question for you. You said you were working on a research project, and I was curious about how you went about maybe if you got stuck in like rabbit holes or anything like that, how you kind of got yourself out of those. I have a bit of research experience, and often I found myself just like spending a long time just thinking instead of doing, as opposed to like when I code and I can kind of see where I'm going, if there's any progress and stuff like that. Were your mentors any help for, I guess, what's the word I'm looking for? Getting you unstuck and having, like, reaching milestones and stuff?
Yeah, definitely. I think the big thing is like starting with a goal, like, and don't forget that goal. Like, if you have a question, don't forget the question. And then like making a game plan based off of that. Like these guys, y'all at the EPF, y'all had like weekly updates that you had to do, and it forced me to write and like to like develop the like help me keep track of the goal, and to like over time see if I am veering off and not answering the question or not answering the sub question that leads back to the main question. I think like just visualizing and remembering what the main goal is. And then also like I was lucky, or I am lucky to be with Alex and Matt, and like you can ask these guys, I don't know, if you can find somebody who knows about the topic and has research experience, they can definitely help guide you and like set the right goals and to make the right game plan. Yeah, but writing out helps, because like otherwise it's really easy to just read stuff and to think you understand what's going on, but then like someone asks you a question where you have to answer based on, like if you're not writing, you only think you're thinking, kind of thing.
All right, thank you.
Awesome. Yeah, thank you so much, Echo. Yeah, we have last 2 minutes to go, and I would maybe close the panel with one more question, because I'm wondering, like, so there is a big difference between the EPF and now being just, without the training wheels. And I think one part of the training or in EPF, or one thing that we did, what you mentioned, the weekly updates. Many people say that like having this routine and the community which pushes you, motivates you to build stuff, right? So I'm wondering, like, how does this change for you now? What keeps you going? What keeps you motivated? What keeps you productive in a way? Whether it's a routine, whether it's some development process, or like, what keeps you going, guys? Yeah.
For a while this past year, I kind of fell off and like got in a really bad spot. But having like people around you in real life, at least for me, helps a lot. And like, if you know the people that you're working with and you believe in the thing that you're trying to build, like the world computer and all the sub-components of the world computer, like, it definitely helps you stay motivated. Don't get like so stuck in a rabbit hole or in your head that you feel like you can't like talk to your people.
I think for me, I'm definitely like a creature of habit, and I think like you're not gonna always like be motivated every day, but what I try to do is like to be consistent. So like I have my routine. I wake up, at a reasonable time. I have, get a couple hours of work done, go to jiu-jitsu, get some exercise, come back and get some more work done. And like my wife always makes fun of me because like no matter where I am, like I'm in Thailand right now and I'm still going to jiu-jitsu, and she's like annoyed. You're like, you're in Thailand, like let's go see temples and travel. But like I like doing, the same thing wherever I'm at, because it gives me like a little bit of structure. And also like I get to work like with really talented team members. And I've learned so much these last 10 or 11 months that I feel so like privileged to be able to work with those people and learn from them. That like, how can I not like wake up every day and do my job? Like so many other people don't have the opportunity that I have, and so I'm really like thankful for it. And that's what gets me excited, I guess, most days.
Habits are definitely helpful. For me, I have the big vision in sight, so I really want to simplify node running, and I just shipped the alpha version, which is just like a month ago or something. So I really want to see the project going, and it's not in a state where I could be proud of it, and I'm really waiting for that feeling that, okay, I'm proud of this, that I did this project. So for that point, I would say I'm pretty much motivated. After that, I think what is going to keep me going is the community. So if I start building the community right now, and people start requesting different stuff on the repository or start using the project, and then that's okay, this project is useful and people want to use it. So that's the two things that I have in mind to make myself motivated in the long term.
Yeah, thank you so much, everyone. That's a really valuable advice because, you know, I mean, we are, it's, I want to say like it's, one more question. We are out of time, so I'm sorry, but we will be here so we can chat afterwards. But now I need to cut it off because we're already after 5 and gotta close it here. But yeah, I wanted to say a huge thank you because, yeah, very valuable advice about the, just the motivation that you just said. I find it very important because it's not even a marathon. It's just like, it's an infinite garden, right? It's this garden which just never stops growing. You still need to trim it. You still need to go. It's you, people like you are here for the long run. And for the fellows here, like, it's been 5 months, and I know it's been intensive, but now is where the real work starts. And now it's when the actual part where the career opportunity of being in this core community starts. And yeah, many thanks for you to inspiring these people and helping them out. You are a great example of I think success in this kind of community, but also you maybe noticed that I run this panel with like no technical question. It's just like about our internal motivations and struggles and feelings and whatnot, because like I believe that people here can relate to your experience because you lived very similar thing. But I want to emphasize all of these 3 people are technical geniuses. They are just amazing in what they do. So I didn't take the opportunity to talk about some cool technical stuff. And I know there is a lot of technical talks at Devcon, but also please afterwards feel free to reach out to any of them, ask them to mentor you maybe or so. Just wanted to highlight that. But yeah, I think that's it. So thank you so much, everyone. Again, thank you so much, Echo, Ethan, Eniko, and all of the fellows. Yeah, thank you very much. The E-pedal. Yeah, that's not gonna happen again. E-pedal, it was very special. So yeah, thanks guys. And fellows, if you don't mind, the people from the Cohort 5, you would like to take a photo together as a Cohort 5. So just yeah, stick around for a moment. And then at 7 p.m. We have a dinner in the Blue Elephant restaurant near the hotel. Folks, you are invited as well. Mentors and fellows, you are also invited if you would like to join us for dinner. Yeah, cheers. Thank you.